Hello and welcome to the MariaDB Server HA High Availability MiniFest 2021 March edition. So we'll start by a keynote in the form of an interview, what really is HA. Then we'll have a number of presentations, each of which has also a question and answer session. And then we'll have, after this pre-recorded part, which is up until now, you'll see a very interactive panel discussion amongst those who have presented and asked questions. And that then will be continued by your own opportunity to join in on Zoom with an interaction with all the panelists. And that's what we call a hallway. It's a first experiment here at the HA MiniFest. So welcome to MariaDB Server HA MiniFest. So welcome to the HA Day, the HA Server Fest, High Availability. We'll start by an interview between Vincenzo Cerbaro and myself. Hi, Vincenzo.
Hi, Kai. Nice to see you.
So let's start from the very beginnings. From a definition, what is high availability?
Well, high availability is a very broad topic, but I think when we look at the general systems, it means that an application is available with minimal unplanned downtime.
So minimal unplanned downtime, I mean, how high is the high availability? I've heard several measurements of this, the number of nines and the number of hours or days or seconds per month or year. What's a good measurement for the highness of high availability?
Well, it all depends on exactly what you're trying to do, but I think where you can mostly aim to get as far as you aim to get to is around 2 nines after the dot, so 99.99%. You're probably not going to get any better than that, because that means around 4.5 minutes of downtime per month. And very few cloud providers even provide that high of an uptime guarantee.
Mm-hmm. Okay. So I'm still on this definition part. That makes sense what you just said. High availability has two components, high, and you said something about the altitude, the highness of availability. But what does it mean to be available? Available for what? Is it for reads, for writes, for transactions, for analysis? What is it? What's the availability for?
So if we're taking into account the system as a whole, I think we can just say that as long as all functionality is present, I think the system is considered to be online, and we can go with that.
Okay, so available for the purposes of what it was designed for. Makes sense to me. So now going a slight bit more to the pragmatic and concrete side, what can you delegate to your high availability system? What do you need to do yourself? So in other words, what can you automate?
So the reason why you set up a high available system is you want to make sure that the user doesn't see any downtime. So you need to automate failure detection in some way and failover when a failure does happen. So this is the minimum that you need to make sure that the system is highly available, because you can't have a human respond in seconds for any particular problem. Also, you need to automate reporting of failures. So you need to make sure that your DevOps team is in charge and is aware of a failure that has happened, and that they can fix it until that failure gets compounded by another one, and then your system goes completely offline.
Okay, so the first level of defense is something automated so that the DevOps don't have to respond within seconds or minutes, but the second level is then to ensure stuff longer term. So what are the typical dangers that high availability protects against? What type of failures?
Well, high availability generally protects from things that happen sporadically. So we can have a look at the hardware. So if hardware fails, a high availability system should be able to tolerate a broken hard drive or a broken network connection. So this typically means redundancy. What it doesn't protect against is bugs in your software. So if your software is down because of a bug, it's not the high availability system's fault that it's down. So HA is one part of a very robust system, but that's not the whole part.
So how much of this HA is then implemented through hardware, how much through software, and how much through, shall we say, processes?
Well, I'd say that it's like a tiered approach. You can't make a cake without all the right layers. So you first have hardware redundancy and hardware backups, and that's how cloud providers generally give you the according to their service agreement uptime. But then you need to be able to handle particular problems in software. So that means you need to be able to handle additional load that sometimes happens. So in some sense, scalability melds with high availability because you usually can't have one without the other.
So are they, you say that HA needs come bundled with scalability needs. So are they in conflict or do they pull in the same direction?
I think they usually pull together to get you the right, the right system, because you can't, if the system is online, but it can only handle 1 or 2 users, then it's basically offline for everyone else. So what are we supposed to do? And if the hardware itself isn't working, or if, say, you have your database and that one is offline, then maybe your hardware can scale to hundreds or thousands of users, but without database response, the application is still offline.
Right. So you're talking about other systems there. So what does it mean to have an HA system from a database perspective and from an application perspective? Or are those the exact perspectives that you should see?
Well, since we're at the MariaDB Server MiniFest, let's have a look at the database perspective first. So a HA system for databases usually involves more than one computer to hold your data. And that can be either as part of a replication chain or as a cluster of nodes, like, say, a Galera cluster. And then there's an additional layer that you need before you end up with your application, like your web servers and the way they need to scale. You need a load balancer on the database itself, because if everything that gets put into the database goes to one single machine, you're back to square one, where nothing will scale properly.
So trying to get back to the basics and the terminology and definitions, I hear a lot about this hot and cold backup. The way I understood it is that the temperature, hot or cold, refers to the cache being filled with the most frequently used data, so that you would get faster response time directly after a hot switchover. Is that correctly understood?
For hot caches, yes, that is correct. If you're thinking about hot backup, that's a bit of a different topic. That's more like something that you can replace as the system is running, and that's where usually clusters are where they shine. So a Galera cluster can get rid of nodes and add new nodes on the fly, and you wouldn't notice it. With the help of a load balancer, that can also be very transparent to the application.
And that cannot, and that refers to hot. What's the alternative in those scenarios where you have a cluster? I mean, is there a cold way of doing that? Does it mean that would cold then mean to take the whole system down and have some short downtime and then reboot it, or what does it mean?
Yep, and that's why I defined high availability as unplanned downtime, because if you need to swap something, you would plan for that downtime, so that's not part of the HA percentage of...
well, some people argue that there's no excuse for having downtime, even if it's planned. It still is. It should be measured as part like diminishing the number of nines, but I suppose that is a matter of opinion and definition. So, or?
Oh, well, of course, you can plan to not have a planned downtime by always having redundancy. But all these redundancies end up costing way more. So there is a balance. It always depends on what exactly you need and how much you can tolerate as downtime.
Yeah, but from the end user perspective, sure, the downtime is downtime. Of course, if it's during the middle of my night, as an end user, I don't suffer. But many of these systems are 24/7, so it doesn't necessarily help all that much. But I think this goes to show that the definition of what's desirable will depend on the application.
Yeah, it always depends on what you're trying to achieve.
So another definition thing here is, let's say that there is a downtime, either planned or unplanned, and then you have a switchover, hot or cold. So during that time, I feel very, very ill at ease. Isn't the system very vulnerable then? It's sort of HA, because if something fails, it still continues to work. But what if there is a second failure during that recovery time? That's probably not very good, I assume.
That is something you definitely need to take into consideration. So that's why I mentioned that your DevOps team needs to be notified and they need to get to work as soon as possible. So you can define a system to withstand multiple failures, but you need to take a stand as to when do you think this is so unlikely to happen that we're not going to guard against it. You can't.
So I read you as saying that nothing will work according to your exact will unless you first define what your exact will is.
Exactly.
So looking very concretely at MariaDB and comparing it to other systems, say MaxScale, what's the difference in HA options between Maria and MaxScale?
So the big difference is there are actually not that many differences in what you can achieve. You can achieve high availability with both MariaDB and MaxScale. So you have a clustering solution for MaxScale. You have replication solution for MaxScale as well. Where MariaDB tends to shine is that it gives you more flexibility, especially with the use of storage engines. So there are certain deployments like you can achieve high availability, not necessarily with the redundancy part, but with the scalability part. So let's assume we handle the redundancy some other way. You still need to cover scalability, and with particular storage engines like Spider, or what we're going to talk about during the fest, Xpand, you can achieve scalability as well.
Mm-hmm. So what are the challenges with HA from well, I suppose it's from a DevOps perspective, or probably not the developer's perspective. So who is actually going to have to address this issue? The developer, the DBA, or specifically DevOps as a crossing between the two?
So the way you achieve an HA system is by working together with all the teams involved. You can't have one person being in charge of everything. So the DBA needs to make sure the database is up and running and has the necessary scalability systems and failover systems put in place. However, the developer also needs to make sure that he's working according to the constraints of his system. Mm-hmm. So he shouldn't expect that if you need, for example, say 20 nodes in a cluster, when you add so many nodes in a cluster, you can't do so many inserts just because there's so much traffic that needs to go between those servers. So you have to do a trade-off at some point. Do we do 2 clusters and write the application so we can talk to 2 clusters? Do we work with the load balancer and encode the load balancer to do that? So it has to be a discussion across multiple teams. It's not just one person who's in charge of it.
Mm-hmm. Then in all these HA discussions, there's talk of single points of failure, and everybody understands what the single point of failure is, and you want to avoid them as much as you can. But what would be a typical single point of failure that people are willing to negotiate about, or what are acceptable single points of failure? Those are probably difficult choices, but do you have any viewpoint on it?
Well, I think the first thing that comes to mind is if you have a load balancer, you're probably not as concerned if the load balancer doesn't have a backup, because it's probably very easy to get it back up, because it usually doesn't have any state, so you just can start up. However, it's not recommended to have any single point of failure in any system, because when that thing goes down, it is going to cause downtime, and you will not meet your uptime metric.
Sure, but I mean, some places do not have geographical redundancy, so they would be in the same geographical place. And if there's a Fukushima there, that's sort of a single point of failure. But these Fukushimas don't happen all that often. I suppose that's that's part of what you design as well.
And that actually reminds me that having redundancy not in just one place. So there was a very recent fire in one of the data centers in France. And that thing brought down a significant number of websites. But because, and I imagine most people did set up some sort of different geographical deployment, they were able to get back online relatively quickly, although the data center is still not online.
Right. So you've been giving lots of good pointers here, good ideas. And there's going to be many presentations now. Any particular additional pointers you want to give that the audience should think about while looking forward to the upcoming presentations?
So I want the audience to be very critical when they are evaluating an HA solution. They need to put it into perspective as to what they are trying to achieve, because there's no one size fits all, and it all depends on what you want to do. So what the presentations are going to show is a set of tools that you can employ, but that doesn't mean that you have to employ all the tools, any of the tools, or just one or two of them. You need to judge according to your use case what you need to do.
Mm-hmm. Makes a lot of sense. What about going really back to the very topic of MariaDB, choosing a version of MariaDB, is that something that you should have extra on your mind, or is it just go with the latest version, do what makes sense, or is there any particular HA perspective other than go with the latest production version?
Oh, as a MariaDB developer, I'm always going to recommend you use the latest version, the latest stable version.
Yeah.
So we work very hard to make sure that you don't have any problems during upgrades. But I do realize there are certain deployments that require older versions. And because of these constraints, you have to pick the version that works for you. But do note that newer versions of MariaDB usually come with bug fixes or performance improvements that can simplify a lot of your other parts of the deployment.
Mm-hmm. Anything important you still wish to add to beyond the questions that I've asked you?
So let's have a look a bit at. So when I have a checklist of things that I would like to do when I'm trying to set up an HA system. And I mentioned a couple already. So I said that we want to make sure that automation of failover works. And we want to make sure that the DevOps team knows when a failure happens. But one thing that is very seldomly paid good attention to is how we do proper backups, but not just doing backups, but also restoring backups, because you do not have a backup unless you can restore from it. Mm-hmm. So I highly recommend that everyone invest significant time into doing backups and testing recovery from backups, because that is part of the failure resolution part of HA.
Cool. Hey, those were good pieces of advice. Let's see what our presenters now have to say about the various solutions. Thanks, Vincenzo.
My pleasure.
Our first presenter will be Andrei Yelkin, who is going to talk about crash-safe XA and its replication in MariaDB.
Hi, you folks. This is Andrei Yelkin of MariaDB Engineering, presenting to you a tale of undaunted XA, together with my fellow colleague, Suyata Sivakumar. We would like to share some understanding of how XA transactions are replicated, some features that have been observed in this process over years now. Still, our key announcement in this presentation is reaching the level of support for XA as them being fully crash recoverable. This is a novelty, and we're proud to announce that it's not the end of the story. We would also show some nice implications of this progress. So let's start off XA, short for Extended Architecture. It is formally defined as a framework for constructing distributed transactions in this document I'm highlighting. From the MariaDB server point of view, XA transaction is basically the same as regular transaction. Just user has a few more controls over it. Let's look at the picture. On this slide, I presented master in this bold black box, black framed box. You see user actor fits in to master statements of mixed with XA keywords and regular operations inside of transactions, like this update table. So say at this point XA prepare arrives to the server, and when it okays, then this transaction must stay with the resource, with the MariaDB server, basically forever, until it gets committed. But those 16 years back, when XA framework was made into 5.0 of MySQL, at once a bug was reported. It's 12.161, claiming that this promise of recoverability of prepared XA doesn't work. It didn't work. It didn't work in case server was configured with binlog. So in that case, prepared transaction disappeared. It was fixed after 10 years. So it took almost 10 years to get to fix it because of various technical complications. And XA, after all, in processing in the server, transits from various modules, server core, engine, replication, recovery. So all of those must be encompassed. And the solution was made in form of this highlighted 12.161 fixes. They were imported by us in form of this MDEF 742. And of course, we improved Oracle's fixes in a number of ways, having this advantage of working over a patch that they donated, maybe unwillingly. However, we could not fix that time another deficiency of the bug 12.161, which is this bug 76233. claiming that XA is still crash unsafe, but it is crash unsafe already in a tiny windows. I will show you here. So when XA preparer or XA commit arrives at server and at very small actually time window, if server crashes, then yeah, it could be different outcomes. Disagreement between the engine and the bin log about status of that XID. So this MDEV for 21469 crash safe logging of XA that we are presenting covers these tiny time windows. How it's done? Let's look into those red boxes with some sort of looking glass on this picture. XA preparer basically executes similarly to commit of regular transaction. Orange text represents regular transactions as commit. So logic is basically the same. Let us focus on commit first. So commit first prepares transaction in engine. So engine is an actor inside of the master server. And when it's okay, we bin log it. So all the records that correspond to modifications are in one or another format. We have two, yeah, as you know, are stored in bin log. When this is okay, transaction proceeds to commit. And you see that asynchronously with commit, actually, it may go to replicate in a regular synchronous replication. In semi-synchronous, it's not like that. So here is asynchronous, full asynchronous picture. Difference with XA preparer is that it doesn't do commit. This orange line message from transaction handler to MariaDB does not exist for XA preparer. We have this situation, and if crash happens inside of the red oval here, say after prepare, but before writing to bin log, in the regular case, in the orange case, such transaction would be not found in bin log at recovery and be rolled back just by the virtue of the recovery algorithm. But what about user XA preparer? It will be found at recovery in MariaDB as it is depicted here, but it is not found in bin log. However, it would be wrong to roll it back without doing something extra, because additionally to the presence of XID in bin log, to lack of XID in bin log inside of the recovery sequence of bin log files, if XID doesn't exist there, it's not enough to decide to roll the user XA. Because we need to distinguish this unexisting XID from the XIDs that may have been prepared a long time ago. And to make it more clear on this picture, you see crash after prepare. So when server restarts, XA commit and XA commit is not sent, for example, so say there is no this operation, then this XSEED would remain in the server through all the restarts that the server will entertain. So it would transit from one server session to another, and therefore, in order to decide to roll it back, because of this crash, we need to prove that this XSEED is fresh from the last server session. And this sort of method requires some complicated logic of maintaining this notion of freshness of XSEED. And it was offered in analysis of this Oracle bug 7600233. Anyway, this method looked to be pretty complicated, and we didn't go this way. Instead, our method was based on the following observation. If XA preparer comes in and say we would first write to binlog the content of the transaction, and then we go to prepare it in MariaDB. How about it? Let's consider if we crash in the middle of the two. Then apparently at restart we have what? XSEED existing in binlog, and at the same time it is not in MariaDB. However, we have something here. Namely, content of the transaction in binlog is present, right? So you may guess it ahead of me. Yes. How about replay it? So actually roll it forward. It's one of the basic principles of recovery, by the way. So that's how we manage to recover. And let's look at how it indeed works. For that, I show you my server. Here it is. We have XA prepare function with a simulation of crash at some point. Here is a point of crash. I will use it. So we have a client. Let me show the client here. I set up already two tables, nginx.db, MariaDB. They are empty at this time, you see. So nothing in binlog at this time. And let me create first transaction. It's here. So XA will be started, inserting in rocksdb table, MariaDB table, and prepares it. XSEED, just the name, literal XSEED. Yeah. Then I can check if it's here. Yeah, it is recoverable. We see it's in prepared state. We can show it in binlog, can we? Yes, we see it is with GTID 011, and its state, the last event prints out, is XA prepare. So it is in binlog. It can be sent to slave and became prepared on slave. So that's how it works. We can now roll it back. I wanna roll it back. Roll back. See, and we then see what in binlog. Yeah, we have second GTID with 012 as identifier GTID, and XA rollback is what we expect. That's good. So tables therefore must be empty. We can also check that with selects. Yeah, I will use it just from history, empty set, empty set. Good. Then there is nothing to recover. I just showed you that how basically MDF7 to 4, for 2 works. It works good. Then let us crash our server. I do that through debug simulation. Here I prepare a server to crash when? Crash before a last engine prepare. So we have 2. So that means we write into binlog first, then we would prepare in one of the 2 engines, and then we crash here after the first one is prepared. It's sort of complicated scenario, not necessarily very practical, but I just show that multi-engine situation is covered and works pretty much robust. So let me take my transaction again. Here it is, and I go to prepare it. Yeah, I lost connection to the server during query. Where it happens, let us see. It must be over there. Yeah, so this simulation, you see, when HA info next is empty, so loop of all the 100 turns involved in transaction is over. So the last loop, on the last loop before executing prepare on the last loop, that is in InnoDB, it is the second insert is to InnoDB. So right here we crash, and now let us try to recover what we will have. So I execute it, and we shall see XA recover, right? What it speaks. Yes, it says I'm here, and let us commit it now. Yeah, I committed it, and now select TR will show us 1 and InnoDB 1. So we recovered, and that's what I wanted to prove that it works. Of course, these examples are quite naive. It should be rather serious. Maybe stress tests should be shown, but we do that, of course, in the patch that is being reviewed at this point. We do a lot of stuff that shakes server seriously. We do that. What we have gained out of this architectural method, more generally than having XA recoverable, we have the following things. There was some work done for benchmarking of sync binlog and InnoDB flash lock at transaction commit combinations. You know, these 2 parameters are responsible for crash safety on server. This of course means that it implies that I'm talking about just one engine involved. So we have the following results out of benchmarking. I will show you. And the results were very much encouraging. 2 lines here worth of attention. In red, we see combination of InnoDB flash at commit equal to 1. This is default, and sync binlog is 0. It is also default, and it is 0. On this graph, you see latency actually above the magenta, and the throughput is also smaller than in magenta. So 62 here is a number of threads. So you see that magenta, but what is magenta stands for? It stands for exactly a recovery parameters that we would like to have with this method of XA recovery. Roll forward recovery. Sync bin log to 1 and inadb flash log at commit 0 actually outperforms the current default. But at the same time, this combination is actually crash safe. We can afford flash log at commit to 0 because we can replay transaction that inadb say even prepared, but at recovery it lost it. It may lost it if it is 0, right? So, but because we can replay, we will restore it, and then you see that if you have right now your workload as a client consisting of entirely of XA transactions, then you can afford this setup and gain more performance. That's very much viable. So, what else we can say? Yeah, this roll forward method, it's of course not necessarily limited to the XA. Yeah, and we currently trying to extend it, expand it over regular transactions in this 1800-959. This task is under architecture review at this point. We're hoping that we will make it through. Let us see, fingers crossed. Yeah, basically I covered what I wanted to bring today, and I only remains to say big thanks to guys who were helpful enormously to make it this XA, basic XA 742, and as well as this recovery our works done. So Sergei Vaitovich, former colleague, thanks to him, Marko Mäkelä, Sergei Galupchik, Alex Schwenke, my fellow colleagues, and as well as Sven Sandberg of Upstream Oracle, thanks to him for great analysis with me on that method that we didn't do, but it helped us to make it better. Thank you for listening to this presentation.
So, hello. I would like to start by thanking Andrei for his great talk, and also the MariaDB Foundation for having me here for this brief interview to Andrei about his talk. So, hi, Andrei.
Hello, Federico.
The first thing I would like to ask is about recovery in XA transactions after a crash. You mentioned that it can be done via the binary log, and I would like to ask you if it requires bin log format to be raw, or if statement is also okay. And I would like to ask if bin log raw image should be set to full, or other values are also acceptable.
So to the format, requirement is for the single engine XA, so sort of normal case, regular case. Any format works. So as long as server configured with mixed bin log format, which is not really format but policy to convert to a raw format at times. So if it's this way, then server will select the correct format. Should it be statement and should it be raw? And recovery must work with the single engine. With the multiple engines, situation is trickier, and raw format is generally necessary. Well, generally, but again, now we also should consider a relaxed high availability configuration of the engine. If, say, in a DB flash lock at commit is 0, then raw. Format must be raw in this situation.
Okay, interesting. Another great... Sorry.
Yeah, and sorry, I haven't finished the full or not full image of the raw. Yeah, we don't really require a full image, so it could be up to the user.
Okay, another great thing you mentioned is that there is a task in review for extending this mechanism to non-XA transactions, regular transactions. I would like to ask you if you can give us a bit more information, or maybe, I don't know, when do you plan the tasks to be implemented, if it will be implemented?
Yeah, that's a sort of, the task has some history, and thanks to Marko Mäkelä, who actually one of the pushers of to make it through. But at this point of time, I think architecturally it's getting very attractive. So I hope we will finish off all these necessary details in architectural analysis. So far, it's good. And then on the good, very good that we have this patch for XA recovery, which is largely will be reused. So there is a good chance that we, if architecturally everything is fine, we can make it into code within, well, I cannot say time, I just fear to say that, but months, 2 months, in 2 months, 3 months, up to hopefully like that. Wow. So if it will be 10.6, I wish it would, but let us see. Yeah.
Okay, that's very interesting. I really hope it will be done for that version. Another question, can we use XA transactions with Spider?
Yeah, that's a very good mentioning of the one of the major users of XA. And as it is our engine, of course, it must be first to leverage this relaxed high availability configurations on the engine and then gain performance, hopefully. So that's to be seen. And I really hope that Spider will show very good of itself.
Okay, good. As a final question, I would like to ask you what's in your to-do related to the XA transactions. So if there is some task or bug fix that is worth mentioning here.
Well, we having some corner cases, bugs that needs to be fixed. I feel personal duty to complete that, to have everything like packaged in the server. What comes to XA and XA replication mostly. I'm not the original writer of XA, of course, but I had to develop into a lot of details of its implementation. For the replication part, beyond this binlog sort of based recovery, we're also having slave side. So when XA is on the slave, and then it's also an interesting situation how to recover there when slave doesn't have binlog. And as many knows, or who doesn't, slave has this sort of recovery through GTIT position table, GTIT slave position in MaxScale database we have. So, and then in order to recover XA on slave, we need to do some tricky things. They are explained, the design is presented on associated with this 21469 MDEF. So the task that I presented today. So there is an associated task for the slave, and it should be followed soon, but we need time and again also architecture review.
Okay, interesting. Yeah, this was the final question from me. So let me just say again, thanks to Andrei and to the MariaDB Foundation.
Thanks a lot, guys.
Our next topic is going to be a use case transfer-wise, and about obviously MariaDB high availability. The presenter is Pedro Albuquerque.
Hi everyone, my name is Pedro Albuquerque, and I'll be talking about MariaDB high availability in a cocktail mix with Envoy and Orchestrator. For those who don't know me, I'm a database engineer at Wise. I've been working with databases for about 8 years, mainly focused on MariaDB, MySQL, and MongoDB. And outside work, I am a handball player, and I have interest in reportage film photography. About Wise, it was founded in 2011 and rebranded earlier this month from TransWise into Wise. Over 2,200 people work with us from over 70 nationalities. We have over 10 million customers and process around 4.5 billion pounds in transactions every month. I'll leave the rest of the numbers for you to see. I'm not going to go over them. Regarding the data source that we host at TransferWise at Wise, we have around 170 clusters, 170 MariaDB clusters, around 350 Postgres clusters, about 20 MongoDB clusters, and we also we host a few other data stores from ClickHouse to Neo4j and Prometheus. For most of the MariaDB and Postgres clusters, we host them in AWS RDS. For MongoDB clusters, we run them on EC2. For some use cases, we run MariaDB and Postgres on EC2. I'm going to talk about MariaDB high availability. But what does high availability mean? Both primary and replicas should be available, should be reachable. In case you want to do the read-writes against tau primary, then you should focus on the availability of the tau primary node. It means that there has to be an automated failover in the event of a failure. Also, this process has to detect the failure and also avoid false positives. We don't want the process to perform a failover if there is no need for that. We also kind of are interested in this high availability means a reasonable estimation time completion. We don't want a failover to happen in 1 hour, right? So this has to be this time to recover has to be reasonable. And one of the things that we believe it's usually not taken into consideration when we're talking about high availability, but we need to consider if the process that we are and data stores that we are using allow rolling maintenances. This is critical for services that require a very high uptime. Regarding high availability, there are two concepts: the write high availability and read high availability. These are very distinct concepts. For the majority of deployments where you have a primary and replicas, we're talking about a single node for the primary. We're not talking about sharding here. And for the replicas, we can have multiple nodes. To achieve high availability in replicas, modern drivers, they already allow to pass a set number of replicas, and a driver will know basically what are the nodes that are reachable. But we're talking here specifically about write high availability. So there are some considerations, and it depends on the use case, but for our use case, we cannot have data loss. We're talking about financial data and transactions, etc. So we cannot allow data loss, split brain scenarios as well, because the time to recover those will be huge. We want the possibility to be able to perform graceful failovers, and this is useful when we want to perform rolling maintenances. We want to trigger a primary failover. We want as well failovers if primary crashes, and we also want replicas to follow the new primary. And last but not least, a possibility for when there is a failover, the old primary to follow the new primary. We used to run our infrastructure in our own data center many years ago, and I'm just going to go very quickly on how we used to perform the failovers. So basically, we used to run a 3-node cluster, primary, secondary, one primary and 2 secondaries, and the applications would query DNS and would get the CNAME would get based on the CNAME they would get what node they would connect to. So in case the primary would go down, we would have to reconfigure replication. So we would have to promote one secondary, change replication on the other secondary to follow from the new primary, and update DNS. So this would be it. So as you can see, this recovery procedure is manual and slow, and you don't want to do this in the middle of the night. So when we migrated to AWS, we had to offload all the relational databases to RDS because that gave us a peace of mind. So if there was any issue with the primary, we would rely on RDS automation to do the failover for us. But RDS, although RDS is great for our tier 1 services, we lack on some features that we actually need, like the failover procedure. We need it much faster than what RDS provides, and we also want the possibility to easily do rolling maintenances, at least like these two features that we consider are critical to the tier 1 services. So let's check the cocktail recipe I mentioned in the beginning. So there are new components to make this possible. One is Orchestrator. I'm pretty sure you are already aware of this really nice software. It's basically a replication management tool. It has an holistic approach, I guess, a cluster to understand if there is anything wrong with it, and it's very nice to avoid false positives. Basically, we use it to recover our primary in case there is a failure, in case it's down or it is network isolated. So, and it also gives us the chance to manually trigger failover in case we need it. The other component, it's something we built internally. It's the Orchestrator health check. This software is basically a service that is installed on all the database nodes, and it queries Orchestrator metadata to understand, based on some rules, to understand if this node is a replica, if this node is a primary, and if its node is downtime or not. So it queries Orchestrator metadata to get that information, and this software exposes some HTTP codes depending on if we query the primary endpoint or the replica endpoint. Envoy is a service proxy. We use it across the whole services that run in WISE. It's deployed as a sidecar in each one of the services. We use Envoy for all service-to-service calls. We use Envoy for services to call databases as well. And this Envoy, it's the way it knows where to route the connections, the service connections to the database. It queries Orchestrator metadata for each one of the database nodes that live in the listener pool, and will, depending on these HTTP codes, it will route the connections and queries to those nodes or not. So this is a simple configuration of how we set up Envoy. Basically, it's we have two listeners, a master and replicas. And we configure a port for each one of the listeners, and then we configure what are the database hosts that belong to that cluster. So, if let's say database host number 1 is a primary and the other 2 are replicas, Envoy will know that is a primary when querying, when calling orchestrate health check on the master endpoint. If it returns at 200, then Envoy knows that that node is a primary. If it returns a 500, then it removes that node from the master listener, and the same for replicas. So this is the deployment that we set up using Envoy and Orchestrator. It's a procedure that the failover procedure takes about, in average 10 to 15 seconds. It will always depend on if the semi-synchronous replicas are laying or not. But basically, we have this is one of our most simpler deployments. We have one primary and 2 secondaries. Each one of the EC2 nodes run the instance, the MariaDB instance, orchestrator health check, and orchestrator. And Envoy, as I mentioned previously, runs locally on each service. So when a primary is down, let's say, orchestrator will understand what's going on with that, and it will choose a new primary. When orchestrator chooses what is going to be the new primary, it will reconfigure topology. So orchestrator will elect a new primary and will refactor the replication topology. So the old primary will replicate from the new primary, and the other secondary will replicate from the new primary. Because the old primary was down, Envoy is not serving any requests to that node. Then when we disabled the downtime that was issued by orchestrator to the node that was down, Envoy starts to serve requests to that secondary if we have read-only queries. So now it's time for the demo. So what I'm going to do is there is a service that is running on the same topology that I just showed you. And what I'm going to do is I'm going to query the amount of connections on for that server that exist on the primary and on the replica that I'm going to promote. Okay? So basically, you see on the bottom left, that's the current primary. You can see that the service has 34 connections to that node, and on the bottom right, it's a secondary that does not have any connections. So what I'm going to do is I'm going to trigger a failover that will promote the node to as primary. And we're going to see how much time it's going to take. So you can see on the node 1, the connections went down to 0. On node 2, the connections went up to 34. And it was about like 10 seconds. So we believe this was a very interesting setup since we don't require any extra component like MaxScale or Proxy SQL, although those tools are really good. But since we are using Envoy already across the whole fleet of services, and we don't require any specific feature from these two proxies, we thought that this would fit better our purpose. So this is how we did it. So now it's time for some questions. So yeah, less downtime, more fun. We are very happy with this setup. Well, we managed to increase availability for our tier 1 services. So thank you so much, and I'm looking forward to your questions. Thank you.
Great, thank you, Pedro. Very, very interesting setup you have there. So I'm curious about the movement of your HA infrastructure over time. You mentioned that at first you used to run, in your own data center. You had one primary, a couple of secondaries, and then now you have 170 MariaDB cluster, mostly on AWS. How did you get from one to the other? Were you using MariaDB all the time? Which versions? What steps did you take along the way?
So in the beginning, when I joined TransferWise or Wise, I'm still using TransferWise, but I'm still getting used to the new name. When I joined Wise about 4 years ago, we were actually running MySQL 5.6, and we faced a lot of performance issues at the time and lack of some features already present in MariaDB that led us to still in our data center to migrate from MySQL into MariaDB, and then with the growth of the company, the growth of features, and the breakdown of our monolith, we ended up with 170 RDS instances. We grew mostly in AWS. If I remember correctly, we were still in our data center with about 50 microservices and our monolith, and the boom was already in AWS.
Okay. So you mentioned you've got MariaDB clusters, you've got Postgres clusters, you've got MongoDB, and as well as a couple of others you mentioned, ClickHouse and Prometheus and Neo4j. Why that particular breakdown? Where do you find MariaDB useful? Where do you find Postgres useful, MongoDB?
I get a little bit of the history. Postgres was brought in by one of the DBAs that used to work with us in the past. He was our first database engineer, and he brought Postgres in-house to address one of our main problems at the time, which was the analytical database, and Postgres outperformed MySQL at the time, and since engineers, or some of the engineers, had Postgres experience, they started requesting Postgres, right? So now we have like two ecosystems in relational databases, MariaDB and Postgres, with no specific requirements of using one or the other one. There are some examples of probably some extensions that we use in Postgres, for instance, scalability, that some services really require that. But apart from that, it's more if some teams are more comfortable with Postgres or MariaDB. Regarding MongoDB, we use MongoDB to address scalability issues and uptime as well.
Okay. And then orchestrate a health check. Are you planning to open source this at some point?
Probably not orchestrate health check as it is. This was something that we had to quickly develop to work with Envoy. But we'll be looking at having this feature of reporting in an HTTP interface to the orchestrator agents. So we are planning to work together with Shlomi and propose this. So we would be moving that feature from orchestrate health check and integrated it into orchestrator agents.
Did you need to do any particular configurations in MariaDB to get it to work well with Orchestrator?
Yes, we did. Unfortunately, we had to disable MariaDB GTIDs, and this is something I actually spoke with MariaDB developers in Zulip, because Orchestrator, in order to understand the status of a primary, it kind of does a fast restart of the SQL threads, and if that replica is lagging, MariaDB will purge the relay logs if using MariaDB GTID, and Orchestrator will see, hey, this is actually not lagging, so it will promote a lagging node that wasn't supposed to be promoted. So we disabled MariaDB GTID, not generating the MariaDB GTID, but we disabled we are using binlog file and position to coordinate to set up replicas using the orchestrated pseudo GTID. So it's their implementation of GTIDs.
So what are you looking at in future? Any upcoming changes for databases?
Yeah, this setup brings a little bit more of operational toil into our team, since RDS, with RDS we offload a lot of the operational toil. We will be looking at VTES with MariaDB backend, starting from next quarter. We'll be looking at see if we can integrate that. It's a big shift, but we believe that moving to containers, it's something that and reduce the operational toil is something that will allow us to scale without having to scale human resources.
Okay. So that's the main reason for choosing it, really, is looking at reducing load on your team,
and be prepared to scale out in case we need. That's right now there is no need, because we broke down our monolith. And but in the future we will have to scale out, and VTES will give us that option. Of course, running with MariaDB on the backend.
Which versions of MariaDB are you running currently? Are they all the same version, or do you have a mix?
No, we are running We are running 10.3 in most of the clusters. We are on the path to upgrade to MariaDB 10.4, and we have MariaDB 10.4 on the clusters that are running orchestrator, because we have to have the automatic failover. And the reason that we are running at least 10.4 with orchestrator is we need that feature that on MariaDB needs to kill on a graceful shutdown. We need that feature wait for all slaves, so we don't lose data when there is a graceful shutdown. But our plan is to migrate this quarter, is to upgrade all the RDS to MariaDB 10.4, and probably early next year to MariaDB 10.5.
Well, I think that's all we have time for, so thanks very much for joining us, Pedro.
Thank you so much. Thank you.
Our next topic is, strictly speaking, not part of MariaDB Server, but very much tied into it. And it's very much about scalability, not just high availability. It's the Xpand engine, which will be reviewed by Max Meter of MariaDB Corporation.
Hey everyone, and welcome to this talk about Xpand. So I'm going to spend a few minutes describing a bit what Xpand is and a few of the key features of Xpand. This talk is only 25 or 30 minutes long, so we can't go into all of the details, but I will talk about some of the key features of Xpand. So without further ado, let's get right into it. So what is Xpand? So Xpand is based out of the Classic technology that was acquired by MariaDB Corporation around 2.5 years ago. So it was Classic was an existing product, and at MariaDB we have now taken this existing product and updated it a bit and basically tied it to MariaDB. So what it does is that it brings distributed SQL to MariaDB. So in that sense, it's similar to something like CockroachDB or Yugabyte, or even for those who are old-timers in the MySQL world, it's similar to MySQL cluster back in the day, which I myself was involved in as part of my tenure at MySQL. So it has a lot of similarities. All of the distributed SQL have kind of similar features, but the main idea is that you're able to distribute the data across multiple nodes or multiple servers, so that you're not constrained by the limitations of one server. And the limitations could be due to size, it could be to CPU power, or many other things. But the whole idea is that it gives you a flexible architecture that allows you to then scale out more and more as you need more, and without any specific penalties going to it. So basically linear scalability, more or less, which is different to many of the solutions currently available in MariaDB or before Xpand. Now Xpand is a smart engine. It does exist in MariaDB as a storage engine, which means you can connect to it like a storage engine, but because Xpand is a smart engine, it has a SQL parser on its own. You can also connect to it directly and use MaxScale as a load balancer. So there's kind of two ways of connecting to it. I'm not going to talk in details about the difference between these two, but basically, obviously, if you connect through MariaDB, you get all of the features of MariaDB. If you use a direct connection, what in our documentation is called the performance topology, then you basically don't have all of the features of MariaDB, but you have the Xpand's native features available. All right, so let's look a bit further at the characteristics of Xpand. So it's built on a shared nothing architecture, which basically means that the nodes are fully independent. There's no shared memory or shared disk or anything like that. All the nodes have their own hardware, and then they communicate over the network. Xpand is or provides total elasticity. You can add nodes or remove nodes from an Xpand deployment pretty much on demand. Obviously, you have to do some operations to do that, and there are some things done in the background, but from a user point of view, it's pretty much on demand. Xpand is very self-managing in that it does a lot of things automatically behind the scenes, like redistributing data and things. Like when you add nodes, data is automatically redistributed and things like that. And we're going to look at some of the details on how that is done as well. Xpand is fully ACID, basically provides strong consistency. It's not like some of the NoSQL solutions out there where there's eventual consistency, but this is strong consistency. When a transaction has been committed, it's been committed everywhere. There's no way of seeing data in a previous version of seeing data somehow out of date. It's completely ACID. It supports standard SQL. The Xpand nodes themselves, when connected directly, has a very rich SQL parser. It doesn't support all of the SQL that you get through MariaDB using it as a storage engine, but most of it. And one of the cool features that I'm not gonna dig into that much deeper on this talk is how joins are handled, where they're kind of partially executed by each node, and then the node is executed by the first node, then goes to the second node and executed further. So it's kind of a really cool way of handling nodes and kind of optimized for being distributed, as opposed to using something like a nested loop join or something that's the default in other engines in MariaDB. It has continuous availability, basically automatic failover when a node goes down. It basically transparently handles failovers and data distribution, and that's something we are going to look at how this is done. Anyway, so those are the pretty cool features of Xpand, and let's look a bit further at the architecture. Here I have listed an architecture where Xpand is as a storage engine, which means that you do have a MariaDB server in front of the Xpand storage engine. But if you were using the performance topology, you would basically have a similar setup. You just wouldn't have MariaDB server in front, but you would connect directly from the application through MaxScale or something, and then directly to the Xpand nodes. The green box here could be the application that connects directly, or it could also be that you have MaxScale in between. Typically, we always recommend to have MaxScale or a similar load balancer in between to kind of transparently hide things like node failures and adding nodes and so forth. If you use MaxScale, the application doesn't have to be aware of what the current node topology is, which nodes are available, have you added more nodes and so forth, but MaxScale will transparently take care of that, and the applications just have to connect to MaxScale. So I think for the purpose of this example, it's better to look at the green box as MaxScale, and then the application connects to MaxScale. In order to guarantee high availability, you need to have at least 3 nodes in Xpand. Xpand does run in a single node setup, but as it is used mostly for distributed SQL for HA, you do want to have HA, and you do want to have a minimum of 3 nodes. The reason why you need 3 nodes is, of course, to avoid a split brain scenario. If you only have 2 nodes, then it's impossible to distinguish. Because in a network setup, it's impossible to distinguish a network failure from a node failure. With a 2-node scenario, basically, as soon as one node fails, the other node would have to fail as well to ensure that there is no split brain scenario. Hence, 3 nodes is the required minimum, because then if one node fails, the other 2 can continue because they have a majority of the nodes. Right, so let's look a bit at how the data is distributed and what goes on inside Xpand. So in Xpand, each table and each index will be divided into something called slices. Here we're going to kind of look at how it would be done for one table, but this is done in your database. This would be done for every single table. Every single index would have the same kind of distribution. So here we have an Xpand table. It will be divided into what's called slices across the Xpand. Now basically a slice is like a certain amount of rows in the table. It's like a partition, except that you can't really specify how this table is partitioned. It's done basically automatically by Xpand, typically using a hash value of the primary key. Anyways, on this example, we have 3 nodes. So we will have 3 partitions, which is here represented by the different colors. Here you have a blue, a gray, and a green. So basically, each of the parts of the table will go to one node like this. And now, of course, the table, each node has a third of the table. But of course, that's not enough for HA. So in order to have HA, we also need to have a copy or a replica of each slice. So basically, each node will have a slice that it's a primary and a slice that it's a replica. So here you see these nodes 1, 2, and 3. They will have a primary and they will have replica and like this. And by doing this, we basically guarantee that there's HA, because now any of these nodes could fail and we would still have all data available. If the third node fails here, well, the primary slice it had was the green slice, but the green slice also exists as a replica on the first node, so we're fine, and so forth. The second node fails, the gray slice, but that exists on the third node, and so forth. Obviously, 2 nodes cannot fail in this scenario. Now, in Xpand, you can't actually set it up to have more copies of the data than 2, but the default is 2, and for most use cases, that's the best option, because adding more copies of the data makes writes slower, because you have to write in more locations. Like this, every time you write something, you have to write in 2 locations, in the primary slice and the replica of that slice. But in theory, if you need it for some reason, you can also set up Xpand to have more copies of each slice, and you can even set up Xpand so that every node has all of the data. And this actually can be really useful for specific scenarios, because it of course makes read performance faster if all of the data is in each node, but of course it means that it doesn't scale as well, because, well, every time you add a node, it has to have all of the data. So that's something that can be used for specific use cases. But also what's really cool about Xpand is that this is highly configurable, so you can actually set this up per table. So you can have some small table that you often use for references in joins and stuff. So you could have this table set up to be fully available on each node, and then how the other larger table is distributed. So that's something that can be used for optimization purposes. All right, so let's look at how elasticity works then. So we have our 3 nodes. Now this table is divided into more slices than 3. I think I have 3 times 4. I have 12 slices here. Now, by default, you will have at least as many slices as there are nodes. But in addition, there's a maximum slice size, which by default is 8. So as soon as you reach more than 8 gigs, you will get more slices as well. Anyway, this table is divided into 12 slices. They're evenly distributed across the nodes, like we see here. These colors, yeah, I'm not very good at making slides perhaps, but these colors are supposed to represent the different slices we have here. And for each slice, there's a primary and there's a replica. All right, so what happens if we have this setup and we now want to add a node? Let's say our traffic is increasing. We're starting to reach the limits of our computational power on each node. We want to add more to be able to basically scale. All right, so let's go through the process. So first thing we do, there is an empty node added to the Xpand deployment. So basically, you of course need to have the hardware. Then there's a simple command that that says alter cluster, basically add node, and the node is added to the cluster. It will be empty in the beginning. There's a short time period when this node is accepted into the cluster, which is called a group change. And after that, everything is fully available. This node has no data yet, but everything is fully available. Then the background operations start. So basically in the background, the rebalancer starts copying primary and replica slices from the existing nodes to the new node. The purpose of this is, of course, to rebalance the data. So we had our 12 slices distributed on the 3 nodes so that each node had 4 primary slices and 4 replica slices. Now, when we add a new node, basically it will take 1 primary slice from each node, this one, and this one, and it will then take 1 replica slice from each node and copy them over to the new node. So we end up with a new setup where instead of having 4 plus 4 slices on each node, we now have 3 plus 3 slices on each node. And we can see that by that, we basically have changed or been able to balance the traffic and the load more evenly. Well, more evenly on over 4 nodes instead of over 3 nodes. So that's pretty cool. And that's done in the background. You don't have to worry about copying slices or whatever. The rebalancer does it for you. So you basically, you get the hardware there and you do your alter cluster add node command, and everything else is done in the background. So that's pretty cool. Now, what about the opposite? What about removing a node, or if there's a node crash? The operations are pretty much the same, so this works in both scenarios. It could be that a node fails, or that you, for some reason, want to remove a node. Similarly, when you want to remove a node, it's a command. But the same steps are taken if a node crashes. So first of all, let's say this node crashes in this scenario. So node 4 has crashed. First thing to figure out, can this cluster continue? Do we have all of the data? The answer is yes, obviously, because the cluster was set up so that a node can fail. All of the nodes that were primary on the 3rd node are as replica slices on the other nodes. So that's the first thing. It goes into the group change protocol again, where the nodes figure out, can they actually continue? And yes, they can. And then what happens after this depends on a timeout, because of course, if a node fails, it could be that it just had a temporary error and it's going to come back up. So you can actually set a timeout. How long does your cluster continue in a mode where it's more vulnerable? Because here, of course, we don't have copies of all of the replicas. We have all of the data available, but we lost a 1/4 of everything, which means that we don't have copies of all of the data. So there are some slices here where we only have the primary and there is no copy. So it's kind of a vulnerable situation. Right now, if we lose another node, we will be in trouble. But of course, if the 4th node is just rebooting, it's not worth starting to move slices around yet. But so there's a timeout, and once you hit this timeout or time limit, then the rebalancer kicks in again. And the first thing we do is, well, we reconstruct, or we basically copy new primary slices from the replicas. So basically, of course, all the replicas are available. So for each primary that was lost, we take the replica and it's copied as a primary to another node. So that's the first thing. Now we have all of our 12 primary slices available as primaries. And then we do the same thing with the replicas. So we recreate replicas of all of the primaries. So now we have 12 replica slices as well after this operation. And again, this is done in the background, and it doesn't really affect traffic in any other sense than that it keeps the nodes busy. And now we're back to 3 nodes, and we have a copy of everything. So that's basically how removing a node or losing a node is done, because the steps are the same. So that's pretty cool. So you can both add nodes and remove nodes. And the rebalancer does everything behind the scenes. So that's basically the coolest part of Xpand is the rebalancer. So let's look at what the rebalancer does. So with the initial data, the rebalancer is the part of Xpand that basically distributes your data into slices across nodes. It's the one who decides which slices go where and so forth. So that the rebalancer is key already with the initial data. When you have data growth, it also splits large slices into multiple smaller ones. So for example, when you reach your 8 gig limit on a slice, the rebalancer will split it into smaller slices. And then of course these will be distributed across the nodes as well. In some cases you might have skewed data. You might have nodes that are much larger than others. So it does that too. It redistributes data to even out across nodes. Or you might have one node that has more data than others or something like that. You might have hot data. You might have one slice that is used all the time for some reason. The rebalancer would notice this and it will split the slice into smaller slices and redistribute them across nodes. And all of this done again behind the scenes. And as we saw with node failures, what the rebalancer does is, well, it reprotects the data by ensuring that there's multiple copies. So basically, as we saw in our example, when one node failed and we lost the copy of many of these nodes and the primary, but we had the copies, then the rebalancer was the one that made sure that we recreated copies of all of the nodes. So we ended up with in a state where we had 2 versions of every single slice. That's the rebalancer. And of course, elasticity, when you add nodes, remove nodes, it's the rebalancer that makes sure that we copy data. So similar to node failures, it redistributes them or copies them and so forth. You can also set up Xpand to be availability zone aware. So if you're using Xpand on EC2 or some other cloud scenario where you have availability zones, you might want to set up Xpand so that in case a whole availability zone is lost, you still have all of your data available. And basically the rebalancer can be made availability zone aware so that it balances data across availability zones, not only across nodes, but even across availability zones, right? So it's really cool. It's pretty much one of the secret sauce or key features of Xpand that makes everything in Xpand work well. And that's basically the basic intro into Xpand. There's a lot more, obviously. We could go into how joins and other queries are executed and so forth. We don't really have time for that in this talk, so I'm gonna stop here. If you want to find out more information about Xpand, we have, as Xpand was released, so first version of Xpand was released as part of the enterprise server release in December, and now we have the first maintenance release come out last week, where we also put emphasis on the performance topology. We've added lots of documentation, so if you go to the docs section of MariaDB.com, there's a whole lot there, so I would recommend going there. We've also created quite a few blogs that goes into some of the key functionalities of Xpand, so you can also go there to find out more. And of course, I will answer some questions after this talk. So thanks everyone for listening.
So great presentation, Max. I quite like it, and welcome now to the Q&A session.
Thank you, Kai.
So you compared Xpand to Cockroach and Yuga-based and MaxScale cluster, and I think I got 3 key technical takeaways from what you said, and I'd like to hear whether you think that's the right takeaways to have. So number 1 is that Xpand distributes data on multiple nodes, getting away with the constraint to have all data on one server.
Correct, yeah.
Good. And then the second one was the rebalancer. You portrayed the rebalancer as the secret sauce of Xpand that does all the hard stuff and all the cool stuff. So learning about Xpand is a lot about understanding the rebalancer. Is that also correct?
Yeah, that's true. Rebalancer is kind of the automation, the thing that does kind of the things behind the scenes that makes things smooth, like adding nodes and so forth. Because that's the one that makes sure that when you add a node, data goes to the new node. When you remove node, everything is reduplicated and stuff like that.
Yeah. So that's what makes it possible, all the difficult stuff that Xpand can do. And then the third one was what you called performance topology. So that there are several ways of using Xpand. One is as a storage engine over MariaDB directly, or directly, indirectly, however you put it. And the other one is to use it independently of MariaDB, and you call that performance topology.
Right. Yeah. So that's that's what we call it. Yes, in our documentation. So I want to use the same name, right? So that it could be easily found. But because Xpand has its own parser, it allows you to do this. Yes.
Mm-hmm. So then the first question I have is, if you have this performance topology and it sounds cool with performance, so what's the benefit for the end user of using Xpand as a storage engine?
So like the benefit is that MariaDB MariaDB server in itself has a lot more features than Xpand has baked in. So you get the benefit of all of the features of MariaDB. For example, the audit plugin, like if you need auditing, if you use MariaDB server, then you get all of the auditing features. For example, all of the security feature, the password plugins and all that, MariaDB has a lot of these that Xpand doesn't. And of course, you can also then use native or local InnoDB tables and mix with Xpand and things like that. So it adds a lot more compatibility with MariaDB and also a lot more flexibility in what you do.
Okay, makes a lot of sense. So on that note, you touched upon the topic of joins, and I remember from the old days of MaxScale cluster that there was a tricky thing. So what about these joins? I mean, judging from your answer right now, you would sometimes, for the things that need lots of joins, you might pick another storage engine and Xpand and optimize it that way. And you also pointed out that you could do the number of slices in such a way that all data for certain tables would happen to be on every single node. I suppose that's a way to optimize joins as well, is it?
Yeah, exactly right. So I mean, the data is still distributed, so you still have like some penalties when you do lots of complicated things where you have to go to different tables in different places. You do have network hops. It's not as bad as it could be, because if you do a nested loop join, then you typically go and get one row from the first table, then you go and get the second row, and every time you go and get a new row, it's network hops. You will have a lot of network hops. Now, in Xpand, there's an optimized way of doing joining where it builds a program and then it sends it to each node, and each node does its own version of the program. So you kind of do a lot of local computations on each node. But still, it's still more network hops, obviously, than doing everything locally. So that's why if you have some reference tables that you often join with, you can, and they're not that large, you can have those in these what we call all nodes format, where all of the data is on each node, and then Xpand is aware of this and it knows that, hey, this table I have everything locally, so I don't have to. I can basically use it as a kind of as something that does not change. I can just locally look it up and quickly. So
to me, that sounds like a much more positive scenario than what it was in MaxScale cluster, where joins were working more or less theoretically in most scenarios, but in practice they had a lot of response times. And you described quite a number of safety nets and ways to get the joins to be efficient enough.
Yeah, I mean, for me, I was heavily involved in NDB or MySQL cluster back in the day. So for me, this is basically the really bare bone basics is the same, but it has all of the automation and all of the optimizations that NDB lacked in the day, right? So to me, it's very exciting because it's like what I always wanted NDB to have. Now we have this in one product.
Yeah, that's a great perspective to have. So you said quite a lot of things in the video, and you gave good answers here on the Q&A. If I want to learn more, the documentation and the blogs, where should I start?
That's a good question. I would definitely start with the documentation, because in the documentation we've recently added the Xpand part, so it's very new, and it's basically it's not bloated. You won't have a hard time. Hey, where should I start? It's not 200 pages. It's 20 pages, so it's easy to get started in that.
And Xpand, how ready to use is it? You said Enterprise Server December was the first one, and now there's a maintenance release. So is it ready to roll?
Definitely. I mean, we already have customers using it, right? So it's definitely ready to roll. It's also going GA in SkySQL in an upcoming release in a couple of weeks. So it's definitely ready to roll And actually, one thing I forgot to mention is that we now also have a trial version you can use from our website. So it's a lot easier than it used to be in the past. That's something we launched a couple of weeks ago. So it's really new that you can now get it and use it, download it and use it anywhere on-prem.
So you are now on a MariaDB Foundation event, and this is more or less closed source. It's commercial only. So we're used to doing everything open source, and this is obviously not. So what kind of, you mentioned there's a trial version if one wants to try this anyway, even if it's not open source.
Right. Yeah, so you get basically a trial license that allows you to use it for, I don't remember, 90 days or something like that. We're still looking into what to do. Like right now, it's a proprietary license source code. We're looking at different options going forward, but we haven't yet decided exactly where to go with that. But it's something we are looking into actively.
Great. So thank you, Max, for that.
Thank you, Kai.
So, welcome to the overview over MariaDB MaxScale, the database proxy. With me I have Johan Beekman, lead developer of MaxScale. Hi, Johan.
Hello. Hi, Kai.
So, MaxScale is a product by MariaDB Corporation and has a code repository separate from that of MariaDB Server, which is hosted by MariaDB Foundation on GitHub. This is because MaxScale has a licensing which is not fully open source, right, Johan?
That's correct.
So we'll return to that question of licensing later because it does have implications for the user. But let's start with technology. That's what interests us most here. So MaxScale is a database proxy. What exactly is a database proxy?
A proxy is something that sits between a client and a server, so that it, from the client's perspective, it behaves in the role of a server, and from the server's perspective, in the role of a client. So both of them, well, in the best case, neither of them is aware of something being in there between, and that's also the sort of the aim of the proxy, so that everything should work just the way it usually does. But since the proxy is there in between, it can do things as the traffic goes through it. And then a database proxy is simply a proxy that then is aware that the traffic is database related. Well, in practice, in our case, it knows that it's the MariaDB protocol packets that goes through there, and then since it is aware of what the traffic is, it can analyze it, it understands it, and can then make decisions based upon what is going through it.
Okay, so it's like you have a, I'm trying to read what you're saying, that you have the application and you have the database, and in between them, you have a proxy that can do certain things, which we will go into, but from the application's perspective, it talks to one database, and from the database's side, it's serving one application. Is that roughly what you were saying?
That's roughly the way it is. Yes. Yeah. So that's so from the client perspective, it's just talking to one database server, but then MaxScale can, of course, do whatever it pleases then on the other side, so to speak.
Yeah, yeah. So let's go to this, whatever it pleases. I suppose it is whatever the DevOps developer or DBA pleases. What I hear a lot is that MaxScale is used for load balancing, which would mean that if you have, the way I understand it is if you have MariaDB replication going on, then you use MaxScale to direct some queries to some replication nodes and others to others, so that you distribute the load. Is that correct?
That's roughly correct. Yeah. So if we have a regular like master slave cluster, then when the traffic comes into MaxScale, then it can look at the statement and figure out what kind of statement it is, and then of course if it's an update statement, it has to be sent to the master, and if it's a read statement, well, typically any kind of select, then it's sent to some slave in case it's connected to several slaves, and then, well, some statements are then of modify the session in some way, and they have to then be sent to all servers there. So the load balancing really is in the picture then when you have a setup where you have one master and many slaves. Then when a read statement comes in, then MaxScale will see which of those slave servers at the moment has the least load, and then it sends the query forward to that particular slave.
So that would then free the application developer of having to do that, like kind of, I mean, I suppose you can, as an application developer yourself, depending on whether it's an update or a select, talk to different parts of your cluster, but that's going to be a lot of coding about wheels that are already invented, I suppose.
Yeah, and exactly. Yeah. So if you can do all these things in the client if you want to, but that's terribly complex. So now with this arrangement, the client developer can write his code with the assumption that he's talking to a single server. But then behind the scenes, there can be a vast cluster, but he doesn't have to care.
Mm-hmm. Yep. So frees up the application developer, and I think you've already answered this, but MaxScale understands how to send reads to some nodes, like selects to some nodes, and writes to the main top level of the cluster, if we're talking about the cluster.
Yes. So inside MaxScale, there is a parser. So when a statement comes in, we parse the statement and figure out what it is. And then based on that, we send it forward. But this is also like a conceptual, we parse everything that comes in. But behind the scenes, there are then like a cache, basically. So we take the statement and we strip away the kind of stuff which it doesn't affect the character of the statement. So if you make an update, it doesn't matter what table you are updating. It matters that it's an update. Mm-hmm. So that way we basically then cache based on this sort of canonical information, so to speak, what the character of the statement, so that then next time something comes in, we only need to create this canonical version and don't actually need to parse it, which is a much heavier operation.
Okay, so you sort of semi-parse it, but don't do twice the work, first parsing everything in detail in the proxy in MaxScale, and then the nodes would need to parse it again.
Well, not really. So it's just that we need to parse a statement always, but we can do shortcuts, which means that we can get rid of most of the work most of the time.
Right. Yeah, and parsing is, I suppose, only a small fraction of the total cost of a statement, because it's just parsed, it's not executed in the proxy.
Indeed. So actually we have MaxScale has two types of routers, which we call the component that decides where to send something. We have a readcon route, it's called, which is something of a misnomer because it can also be used for write. So it's basically a connection-based router, which means that when a client connects, at that point we decide which server it's going to talk to And that connection then is created, and then it remains the same for the lifetime of the session. So it's basically like a circuit kind of thing we create from the client to the server. Then we have this statement-based router, which was typically used, where we then, based on, make the decision at each statement essentially. And at that point we see which server has the least load before we send it forward.
Okay, so that was about load balancing, but I've understood that MaxScale is not just a load balancer. I looked at the documentation and it didn't say load balancer only. It said high availability, like the topic of this server MiniFest, and the other keyword there beside high availability is scalability. So what does that refer to if it's not just load balancing?
Well, the thing, so MaxScale is capable of, say, if you have a typical this kind of master slave setup. So, and when the client connects, we make a connection to the master and to a number of slaves. We can make, depending on the configuration, we make the subset or to all of them. Anyway, so then if one of those slaves goes down during well, the client session is alive, it doesn't matter, because then we can pick another slave for that purpose. And we are also capable of, so during use, we track the session state, so we are aware of what kind of modification has been made. So if a server goes down and then later comes up, we can connect to it anew and then seed the session so that the session state is the same as in all other servers that have been alive, and then we can take it into use. So even if servers go down and come up again, the client doesn't need to care about that. And it doesn't sort of stop there, but we are also capable of, so if the master goes down, then there is just one of those. So then we need to perform a failover, and that's also something MaxScale is capable of. So then if that happens, MaxScale picks the most appropriate slave, makes it into the master, redirects all the existing slave to that master, and then continues. And this was added rather recently, this kind of transaction replay mechanism. So MaxScale can, when the client is executing a transaction, we make a note of all statements that the client sends, and then calculate the hash value on all the responses that are sent forward to the client. Well, then if at that point the master goes down, and then of course there's this machinery behind there that takes a new master into use, and then when the master is up and running, we replay the transaction. We send all the statement to this new master, and of course again get responses and calculate the hash value. If they match, then we just discard the result because it was identical to what we got from the first master, that is, the client has already got it. Then if this all goes nicely through so that all the statements that are replayed produce exactly the same result, then we just allow the client to continue. So the client can be connected to what it thinks is a server, and there is this big cluster behind it. Then the master goes down, failovers are performed, a new master is taken in use, and the only thing that the client experiences is a slight delay when this is happening. But of course, it doesn't work always. For instance, I mean, if you make as part of a transaction, you make a select asking for the current time. Well, that's going to be different when you replay the thing, and then there's going to mismatch. And then in that case, we have no option but to disconnect the client. But in sort of a typical setup, this works very nicely.
Okay, so that was interesting. That was a load of stuff. So I think what I got away from that was high availability is something which you should look differently upon when it comes to the availability of the replicated, shall we say, read-only nodes and for the master itself. So you're saying that it's highly available, not just if a node is failing, that is usually just a slave part, but also if the master fails, then the failover scenario will be such that through MaxScale. It promotes one of the slaves to be master, and then after that does you were describing the hash values and all of that to ensure that state is correct in all of the places as far as it can be done, given some complications such as selecting the current time. I got that part, and I think that explains very much the role of MaxScale in high availability, not just load balancing. But I do have a follow-up question on this, and it might be a semantic one. Scalability. So what is different? In what sense is scalability different from high availability? And if it is different, then how does MaxScale support specifically scalability as opposed to the functionality you already described in HA?
Well, in this scenario, you could add a new slave to this cluster and take it into use without having to take MaxScale down in between. So you can add a new node, and it will be taken into use transparently.
Okay, so let's say that I want to increase the number of replicated slaves there. There's something I can do so that the application as such stays online all the time, and I get more firepower.
Yes.
And it then takes care of ensuring that all of the transactions are in the new node as well, including, I suppose it takes some kind of, you start by some backup scenario, and then you replay from the logs what has happened since that backup was done, or how does it work?
That's not something that MaxScale can do. So you have to ensure from the outside, so to speak, that the server, that the new server is up to date. So you just set it so that it then starts to replicate from the master, and then you take it into use when it's
right. So it's your task as the DBA or DevOps to ensure that the node is up to date. But once it is up to date, it can be seamlessly scaled into MaxScale.
Yes, indeed.
Okay. So now we've spoken about load balancing, about HA, and about scalability, but I also know that there's some kind of a security aspect of MaxScale. And from what you already said, through the fact that MaxScale parses the statements, it also probably parses all of the things that are related to security. But what does that mean from a user perspective? What kind of functionality can you add? Is it a firewall, or what does that security functionality mean?
So the architecture on MaxScale is such that when a statement comes into MaxScale, it then passes through a number of filters. They can be 0 of those or many. Then it comes to this router component that then sends it forward to the backend. So one such filter is what we call the firewall filter, and you can have it in that processing chain, and then there are rules that can be applied. So a simple case is that it blocks all delete statements that do not have a where clause, and things like that. So prevent you from, you can insert it there and in the chain, in the sort of processing chain, and then prevent these kind of stupid mistakes from happening. And
are you talking now about stupidity when it comes from stupid developers? We all make mistakes, or are you talking about external attacks, or both?
Well, I was talking about silly mistakes. So you can of course use it also for so if you fear some kind of malicious attacks, so you can then prevent things. But it hasn't been assessed in the way as a true proper security solution would have to be assessed by an external party. So that's why I would say it's more for the primary intent is to use it to protect against this kind of mistakes that can happen, and sort of rather a soft kind of firewall, let's put it that way. So if you really would like to have to use it as a hard security solution, then we would have to sort of review the whole mechanism more than we so far have done.
So I might have further technical questions as well, but I'll take a detour now into licensing. So MariaDB MaxScale is licensed under BSL, Business Source License. What does that mean?
It means that you essentially have to pay for pay if you intend to use MaxScale. But there's a twist, and that is that this BSL automatically turns into GPL at the so-called change date.
Mm-hmm.
And that is that when we make a release, license is under BSL, and then we specify what the change date is. And at that date, it then turns into GPL and is free to use by anyone in any context. And there is also this other thing that the BSL license itself says that this change date can be a maximum 4 years into the future. So at most 4 years. And we basically, it's part of our release procedure that when we make a release, we sort of bump the change date 4 years roughly into the future, and that's it.
And when you say release, I suppose it's a major release, or is it also a bug fix release?
Bug fix release. We always bump it forward.
Mm-hmm. And so, what's the? I suppose MaxScale is already older than 4 years, so there are some open source versions of it around, are they?
Yes, I mean there is. I mean the original 1.x series, it was GPL all the way. BSL was introduced 2.0, and the versions 2.0, 2.1, and 2.2 are now GPL. And this, and there's also this kind of difference between. There's a slight difference between like the end of life and this sort of BSL to GPL change date thing. So, for example, version 2.3 will reach its end of life by the end of this year, and at that point also, like the first versions of 2.3 will have turned GPL. But for example, if we were to release a 2.3 maintenance version today, then that would turn GPL 4 years from now.
Okay, so what this means, I mean, if I have in my shop, I have a strict open source policy, then I would be doomed to have old releases, and if not, I can go. I mean, if I'm allowed or want to buy licenses, then I can go with the latest one. Is that the sort of short story?
Yes, that's a short story. Yes.
And do I buy specifically MariaDB MaxScale licenses, or I mean, this is not a commercial presentation, but I do need to understand the basics of it. Is it bundled into something else, or do I buy MariaDB MaxScale?
To be perfectly honest, I'm not sure exactly how it works, but yeah. So in most cases, it's to the best of my understanding, it's a kind of a support contract that you have with MariaDB Corporation, and that then involves MaxScale as well, or includes MaxScale as well. But
there are, I mean, it's a fully functional version of MaxScale. I mean, you say ugly words like end of life and all of that, but it's technically completely workable versions of MaxScale that are GPL that I can go out and try without any sort of constraints, I suppose.
Absolutely, yeah. So this end of life only means well, basically at the moment when the first version is the change date for the first released version turns into GPL, and at that point we move forward.
Yeah. So it's end of life of commercial support, which I don't get anyway if I am on the GPL version.
Exactly. Yes.
Okay. So what features do I miss out on if I use those old MaxScale versions?
Well, it's we obviously, whenever we make a release, we add some new features of various kinds. So for instance, like this read-write splitting, it has been from the very start, so it's there. But transaction replaying, that handles this the disappearance of servers and all that kind of stuff, have been introduced in later versions, and I'm not I don't recall now if, for example, transaction replaying is not part of 2.2. Then here we have included also a cache in MaxScale. That I think is in a version not yet under GPL. So I mean, it's the usual story. Whenever you make a new release, new version, you introduce new features. But most of the features on MaxScale are kind of incremental in their nature. So we expand the functionality that already exists. So that's really what you then miss out of the latest things. And of course, I mean, like we fix bugs all the time and so forth. So it's fair to say that the more recent MaxScale version you have, the more stable it is.
Yep.
I mean, as usually is the case.
So in another presentation here at the MariaDB Server HA MiniFest, there's talk of proxy SQL, and that sounds like another proxy. So what does MaxScale have that proxy SQL doesn't? Can you compare the two?
Well, I actually, to be perfectly honest, I'm not so well acquainted with proxy SQL that could make any kind of intelligent, give an intelligent answer to that. It's been quite a while actually since I used it the last time, but well, they are all available there out there, so it's easy to grab them both and make a comparison and try them out.
Mm-hmm. So now back to technology. I read about plugins. What were plugins? Is a magic word in any kind of a software. It's supposed to mean something good that you can do with that you can plug in easily without upgrading, or is it something that you buy on top of it? What does plugin mean in the context of MaxScale? Well,
it mostly means, I mean, it mostly relates simply to its architecture. So the MaxScale, the architecture of MaxScale is such that there is this sort of core component of it, core part of it, which handles threading, logging, and all that kind of stuff, but it doesn't actually provide any meaningful end-user functionality. And then we have protocol modules that can talk a particular protocol, for example, the MariaDB database protocol, of course, and then filters that do these things, like the cache filter and the firewall filter that was mentioned. And then we have the routers that then direct the statements forward and so on, connect to the backend. And of course, these monitors that are capable of monitoring this particular kind of clusters. We have monitors for regular master slave, Galera, Xpand, and so forth. So it means that, well, in practice it means then, of course, or it forces the kind of compartmentalization of everything. So it's rather nicely partitioned, and also makes it forces architectural clarity, and then at the same time, of course, makes it easy to add new stuff without having to tear, the whole thing apart. But there are these. But it does sound like it's mostly something that helps you as a developer and to create an architecture that is good for MaxScale. It's not something that I really need to know as an end user of MaxScale. Not really, no. So what's the latest version number that you are on in production now? 2.5. 2.5. And are you working now on 2.6? And if so, what are the features? Is there something you can say about what features you're working on? We are working on 2.6, and it will be released next summer at some point. I myself am now working on a rather cool feature, I think. This support for the Mongo protocol. So you will be able to connect via MaxScale to a MariaDB database using basically any Mongo client, and then behind. Why would I want to do that? You may want to do that if you want to have a sort of one-shop solution for your database needs. So you need a regular SQL database for something, and then you would like to have a document database for something else. So then with this solution, you can use the client thing of your solution can be based on Mongo, which is what a lot of people are familiar with, and then the backend. That's backend. You don't need to have a separate database, but you can use the MariaDB database.
So you somehow translate stuff that is not SQL at all into the SQL protocol.
Yeah, I mean, indeed. So this the Mongo protocol, which is object-based and so forth, and these JSON objects and so forth. So they are then inside MaxScale translating. So basically, for all of these Mongo collections, we have a table that only has an ID and a document column. And MariaDB has a lot of these JSON functions, and using those, then we can manipulate and search and so forth. I mean, of course, there are limitations, but it's still it's kind of nice. It
does sound cool. I wonder what kind of limitations there will be, but does sound very, very interesting. So if I'm now interested in MariaDB MaxScale, where do I go to learn more? Do I read about it on the knowledge base, or where do I learn more?
Well, we have the source code is in GitHub. That's of course the ultimate reference, and the documentation is also there, which is then imported into the knowledge base. So all documentation of MaxScale is available in the knowledge base and in GitHub.
Okay, so you have the same documentation in GitHub and in the knowledge base.
Yes.
Cool. Yeah, I think we get a lot of requests for GitHub to be used more. So it's nice to hear that you've done that in your MaxScale. So what have I missed to ask you?
I don't know. Oh yeah, well, one thing I can mention. We were talking about this high availability. So there is also this case, of course. I mean, like MaxScale handled the case that some servers in the cluster goes down.
Mm-hmm.
But then, of course, MaxScale can go down.
Yeah.
So you just move it to one place. So what you can have now is that you can have a cluster, then you can have two MaxScales in front of it, and they are both monitoring the same cluster. And then in front of those, you then need to have some kind of solution that switches between those, and that you can use, say, well, some other kind of simpler load balancer that makes the switch, or then you can have a connector that is capable of switching between two. And the problem is that when you have this two MaxScales monitoring the same cluster, is that which one of those is responsible for performing the failover. So both, of course, can't do this because that would cause chaos. So what we do is that we use there are these server locks. So both of them attempt to take a certain locks from each of those server nodes, and the one that is capable of grabbing them all then has this responsibility to perform the failover. Now, if that goes down, then of course it means that this other, which all the time attempts to take those locks, then gets those, and then the responsibility moves over, and there is no need for any kind of third party for orchestrating the whole thing. The third party is implicitly the server, but there is no explicit third party orchestrating this whole mechanism.
Cool stuff. So on that very technical note, I think we should conclude this. So thank you for a very illuminated description of MariaDB MaxScale, Johan Wikman.
Thank you.
So next up is Federico Razzoli, and he's going to be talking about the combination of Galera with Ansible. So automate MariaDB Galera clusters deployments with Ansible.
Hey up, welcome to my talk about how to automate MariaDB Galera cluster deployments and configuration management using Ansible. A couple of words about me. My name is Federico Razzoli. I'm the founder of Database. I'm also a database consultant for Database, and I basically use MariaDB since before it became stable, and MySQL since forever. Database is proud to be MariaDB Foundation technology partner that contributes contents to the MariaDB knowledge base, In particular, we contribute contents for a section about automation of MariaDB. That is the reason why I mentioned this. So you can find a section about how to use Ansible to automate MariaDB. If you don't know MariaDB knowledge base, I really suggest you take a look at it because it's excellent. And also it's a wiki, so anyone, including you, can contribute contents, fix mistakes made by others, and so on. Before starting, I want to tell you that this talk is based on a working, complete example that you can find on GitHub at this URL that you can see. Again, it is a working example, and it installs everything you need in real life in your cluster. It is based on database opinions, and in particular my opinions, which are not universal truths, so feel free to express objections or different opinions, and I will be very curious to read them. In this talk, there is not enough time to describe the whole example, so we will only see the general ideas behind it, and we will see at some hopefully interesting details. So let's start, and the first thing we want to look at is inventories. Inventories are the files that say which servers we are going to manage using Ansible. You can also use, dynamic inventories in Ansible, but we will not look into this. So we will have only two inventories called production and staging, and this is what they look like. They are almost the same. They define basically two groups, one for PMM, which is the solution for monitoring that we're using, and a group for the MariaDB nodes, which are part of the same cluster, a 3-node Galera cluster. In each group, you can see we define the nodes. It's interesting that even if the group contains only one node, we still want to define a group for that, okay? And we want to follow a consistent naming convention. So even the group PMM, which has one node, the node is called PMM1 because if one day we decide to have a second PMM server, it will be called PMM2, and we will not break any naming convention. It's not very common, honestly, to place variables in the inventories, but we are doing it here because these particular variables are PMM, hostname, and port, so they are actually related to an inventory. And if for some reason we change the node that we are going to use for PMM, well, we will only need to change the inventory and nothing else. The only difference between production and staging inventories is the actual IPs of the machines, okay? So in every other respect, they are the same. And this is very important because it means that with the same command, almost the same command, we can deploy to staging and then to production. What we need to change is only the name of the inventory. And, this leads to have a much better test set of commands we want to use. The next step is, of course, at least one play. If you're not very familiar with Ansible, you can see that all it does is associate the hosts to the roles. Okay. You probably see something uncommon already, but we're going to talk about it. So the next thing we're going to talk about is the roles. I don't know if I'm allowed to drink coffee, but I need it, sorry. So the most important role is actually a meta role called MariaDB Galera Complete. And it actually includes a list of other roles. You can see the list of the in the slide, or you can take a look at the meta directory, the main.yml file, and basically this is the file that defines meta information about a role and include the list of dependencies of the role. Okay, so this is important because in the play we only associate hosts to this meta role and not to the list of base roles, let's call them this way. So if the list of base role changes and we have many hosts of many groups associated to this meta role, well, this is basically less error prone. Okay, let's proceed. Let's see what these base roles are. The first is Linux for MariaDB. Basically, it configures Linux optimally for running MariaDB. Then we have Crony, which basically installs an NTP client, which is useful because we are running a cluster and we have monitoring. And if we have a clock drift, so basically the clock time in the nodes does not match, well, this will be a problem. This could break both the cluster and monitoring, especially the monitoring, actually. Then we have the main role, which is MariaDB Galera. Then we have MariaDB permissions, which creates or maybe drops the needed permissions, users and permissions in the database. And this is not necessarily bound to MariaDB Galera. This could be used, for example, for standalone MariaDB servers, or maybe MySQL, Percona server, and so on. Then we have MyDumper for backups, which is actually probably the best logical backups tool. Then we have, and it's important to put it in a separate role actually, because we could install MyDumper on a host that doesn't run any database, and yes, it makes sense. Then we have PMM client for monitoring. Again, it's important to have a separate role because PMM can monitor other database types, not necessarily MariaDB. And then we have cron jobs. This may sound a bit weird to you, and if you're curious about why I put cron jobs in a separate role, well, I will explain this probably at the end of the talk. So let's see some highlights, so the most interesting details in my opinion. Okay, so in this slide you can see a small snippet, well, a single task from Linux from MariaDB. If you're not familiar with Ansible tasks syntax, the key here is with nested key. Basically, we're looping over two arrays, the list of allowed ports and the list of IP tables chains. And for each combination of port and chain, basically, we are opening it. So basically, we are making sure that the node is reachable from the outside. And here you can see the actual array. The array is, well, an array of objects. Basically, you can see every port and the corresponding protocol, TCP or UDP. The first is normal MariaDB port, and the other ports are the one needed by Galera. And you can also see another array, which is kernel parameters. I didn't show the corresponding tasks for brevity, but you can see it in the repository. And basically, well, you can guess what it does. It tunes some kernel parameters. And the only thing we're tuning here is swappiness. We are setting it to 0. Some would say this is questionable because basically many people set swappiness to 1, which means that Linux will allow swapping only when the alternative is that a process crashes. And this is okay on a standalone server for sure. But we are talking about a cluster, and honestly, if we have proper automatic restart, I'm not too afraid of a single node crashes. I'm more worried about a node becoming too slow, probably because it exhausted the RAM memory. And if it happens, it can slow down the whole cluster. So personally, I would prefer the node to crash. But again, this is just an opinion, and you can set swappiness to 1. I'm just showing you how to do it. And I'm just showing that you should actually do it. Then we have 2 snippets from the MariaDB Galera role. The first snippet is in may.yml. I'm sorry. It basically includes another file, which is validate.yml. The file is a bit longer than you can see here, but you can see one example task, and basically you can understand that it validates variables. I think this is quite important. Why? Because in a complex environment, even this example, you have a lot of variables. If you change something at some point, maybe not just in the variables, maybe maybe you make some in-depth changes. You want to check that everything is still correct. Because if it isn't, well, hopefully when you try to apply your roles, Ansible will fail. But it could be a bit hard to debug and understand why it failed. Especially if you have variables that are used in multiple roles. For example, you could have some variables with some pets, and these pets are needed by MariaDB Galera role, but also by, I don't know, a backup role, for example. So it's better that every role checks that the variable it needs are correct. Okay? If not, well, you can see this is an assertion. If the condition is false, it will fail and print an error message that you specify. Then, this is also interesting. This is another task which includes another file, which is clear.yml. Basically, what we're doing here is including a file that deletes and recreates the data directory. This is something that actually you want to do sometimes. For example, if your server has corrupted data, you want to reinitialize it from scratch. But the problem is Ansible is supposed to be idempotent, and this means that you should be free to reapply the same role again and again, even if your server is already running in production, and you shouldn't do any damage. So the key here is the when key. Basically, we are including this file clean.yml only if we defined a dbinit variable. Okay, we can define it in the configuration files, or we can pass it as an environment variable. It doesn't really make any difference. Then this slide shows how we specify the information about our nodes. Okay, so we have a cluster name variable, which is, well, not much important, but then we have cluster hosts. And then this is an array, and each element represents a single node. And each element is also an array, an object. An object with these properties, node name, public IP, and private IP. And then you may wonder why we also have a separate array called private IPs. Well, actually, this is not clear. I don't like it, but there are limitations in how we can loop over arrays of objects and access certain properties. So basically, it was not possible, or at least too difficult to do something, and I preferred to create a separate array for private IPs. Again, even if it's not clean, in this particular case, it's probably not the end of the world. You just need to update it when needed. The next slide shows another interesting task, because if you look again at the when key, this key checks if this is the first node of a cluster. So the node defined as a first element in the array, okay? And also if the cluster consists of more than one nodes. Okay, because in this case we want to perform some special operations. Well, in this particular case, what we're doing is copying to the server a particular file, which basically sets WSREP cluster address to only the address of this current node. Okay, and this is useful to bootstrap. You probably know that this is not the easiest way to bootstrap, because we could simply use the WSREP new cluster option. But the thing is, well, we are automating things here. So I prefer to use a method that works even on older MariaDB versions, and also on MySQL MySQL with Galera, or Percona server with Galera. Also, in any case, even if you don't like it, well, this particular check can be different, can be useful in different situations too. For example, when we want to restore a backup, because if we want to do it, we want to restore it only on the first node, not on all the nodes. Otherwise, we will try to restore 3 copies of the backup, which doesn't make sense, right? So this other slide shows what MariaDB permission does. Basically, well, this is just a high-level description, and well, the permissions themselves and the users themselves are defined using SQL statements in 2 files. The first file, as you can see, represents groups of permissions, a logical group of permissions. And the second file is the permissions for this particular node. Okay. you will not use it for a cluster. But anyway, the idea is the first file is more generic and the second file kind of overrides the first, okay? So we prefer to use SQL statements for a series of reasons. If you're curious, well, just ask. Anyway, I will just say that it's probably simpler and more flexible. This is the last slide, and it's about the strange role, which is cron jobs. So, again, you would probably expect that if a cron job is related to backups, for example, it is defined in a backup role. But the thing is, you want to kind of coordinate your cron jobs. Okay, so, what does it mean? Well, if you have several cron jobs and maybe some of them are heavyweight, you don't want them to run at the same time. You want to make sure that they run at different times, and they should be times when the server is not overloaded. So you may prefer, I prefer, and you may prefer to have an array of jobs defined in only one central place. And this is the purpose of this simple role. So again, this was the last slide. We finished. So thank you very much for attending. And I'm very curious to read your questions. Bye.
So, hi, Federico. Thank you for your talk. It was very interesting, and I have some experience with Ansible. So for me, I learned some stuff in it. So very nice. And I had some questions. So what do you suggest? Is it very important to automate MariaDB configuration? Why is it just a fashion thing, or is it a hype thing? What's your opinion on that?
Hi, Faustin. Yeah, it's a great question. And yes, I think it is really important, not necessarily from the beginning, because maybe you're starting a new company, maybe you have only one server and you don't really need to automate it. But this is a need that you will have very soon, right? As the workload grows and you will have repetitive tasks and you will add new servers. If you do this manually, you will hang yourself, because at some point you will realize that you are spending more and more time doing manual tasks that could be automated. And you will make mistakes, and these mistakes will consume even more time and will probably waste money for the company.
Okay, and what about, as I think most of the companies, they don't start by automatizations with Ansible or other configuration management system. What do you suggest? Is it too late, or is it always a good thing to do to start automatization even after you have already deployed your stuff?
Well, of course, as things progress and you have more servers and so on, it may look more difficult to start to automate things. But actually, you could start from simple tasks. So, for example, you run backups manually once a day. Well, you can write a bash script, and you run also other tasks that are repetitive. Well, you can automate them by writing more bash scripts, and then at some point you will realize that it would be easier to have Ansible or Puppet or anything else rather than a set of bash scripts. And then, well, it will be easier, right? You will just have to kind of translate the logic from bash to, for example, Ansible. So if you do it gradually, it's not really a huge effort.
Okay, so this offers me a very good transition, because you spoke about bash, and I see that in your project, in the GitHub repo that you have created, you are using Bash and you are using SQL for applying some tasks in your playbooks. And my question is, why don't you use the MySQL user module or the other modules that comes with Ansible and that are maintained by the community?
Okay. I don't think my opinion here should necessarily be universal, but the thing is, I use the shell module because it's very simple and it's universal. For me, when I use anything else, the main reason is because the shell module is not idempotent. Okay, a command will be executed every time I call that Ansible playbook. So, for example, I could use, I don't know, iptable module, for example, to create a rule if it doesn't exist yet. Okay, that's a good reason. But in the case of MySQL modules, well, I could use MySQL query to run a query, but again, that query will be executed always, every time I run the role. So I don't see a real advantage here.
Okay, so this is interesting because I had the problem with the MySQL replication module because it didn't support GTID positionings at the time I used it. So I had to use a specific SQL command and I couldn't use it. So I don't know if we have lots of time, but don't you think, what's your opinion that should MariaDB Foundation help the community, help Ansible community to create specific modules for MariaDB? What's your opinion on that?
Oh, if you can, yes, absolutely. Because actually, that's a very good point. The modules are created by people who basically have some work to do, probably, right? If they don't need a certain feature, they will probably never implement it in the module. But if you use SQL directly, you will have many, many more features. That's another good reason to use SQL directly, in my opinion.
Okay.
Unless MariaDB Foundation starts developing a specific module.
Okay, very interesting. Okay, I think we are finishing our time. So thank you very much for everything.
And thank you.
Bye-bye.
Bye.
Our last presentation is by Ruslan Sinitsky, auto-clustering vertical and horizontal scaling of MariaDB within Jelastic platform as a service.
Hello everybody. Today I will talk about MariaDB as a service, specifically about auto-clustering, about vertical and horizontal scaling within Jelastic platform as a service. My name is Ruslan. I am co-founder and CEO of Jelastic multi-cloud platform as a service. Our platform was designed for developers to simplify their daily life while provisioning new service, configuring them, creating complex topologies for load balancing, availability, as well as for configuring complex continuous integration and delivery pipelines. So, at my presentation, I would love to talk about downtimes and how to avoid these downtimes, what kind of functionality people introduced and specifically Jelastic offers for its customers. So, and while this issue is important, because when downtime happens, companies lose money. There is a statistic how much money large companies lose per minute, per hour. So, but it's not only about money, it's also about reputation. You lose existing customers, they become unhappy, and you lose potential customers. So downtimes are really bad. But also, there is another problem. It's not an easy to avoid downtimes if you use standalone installations. You need to configure clusters for high availability and also for disaster recovery, for example. But such kind of topologies, they are complex to configure and specifically to maintain in the future, to do software updates during application lifecycle. So, to solve this problem, many companies that specifically develop databases, they move to database as a service direction. And Jelastic as a platform as a service moved to this direction as well. And there is a simple comparison how much work you need to do if you host MariaDB on premises, right? You must do everything by yourself. And when you host MariaDB on infrastructure as a service platform, so infrastructure platforms offer just automation regarding operating system and hardware maintenance. And then if you host MariaDB on Jelastic platform as a service, it gives you much more automation. So it releases your time, it releases your efforts, and you can focus on other things, on your business logic, right? So, and you can see the list of functionality Jelastic offers by default for every customer. So, but this is designed for self-managed service, let's say, right? You can also request managed MariaDB on top of Jelastic platform service, and one of the certified Jelastic providers will be able to offer fully managed service for you. So let's talk a little bit about what kind of automation Jelastic offers out of the box when you do self-managed, when you use portal for developers, for example. So we take care, specifically I want to focus on high availability configurations, on configurations for automatic horizontal scaling, as well as vertical scaling, and some optimizations of the default configuration. So all these tasks we do automatically for you. And we will talk a little bit more today how we perform these configurations and how we deliver this automation for you. So, but a little bit more about Jelastic partners around the world. Jelastic, we are, as a company, we are a software company. We focus on development of our software platform. We collaborate with many hosting service providers around the world, and we enable them to deliver modern cloud services, modern automation to different local markets. Today, Jelastic is available in more than 100 data centers, and we collaborate with more than 60 different service providers. So our network is growing almost every week. And specifically about MariaDB, we love MariaDB. And our customers love MariaDB. MariaDB has the second place among the other databases. It's pretty popular within Jelastic user base. Now coming back specifically to how it works within Jelastic. At the screenshot you see the topology wizard, where you can choose MariaDB as a certified container runtime. So you can choose different versions here, and there is one button. When you enable this button, the platform will switch on auto clustering mode for you, and you will be able to choose different replication schemes. There are 3 replication schemes that supported for MariaDB. Standard one like master-slave, master-master, and Galera. There is also possibility to increase number of resources available per each container, right? And there is also possibility to increase number of containers. So in other words, this reflects vertical scaling, and these buttons reflects horizontal scaling. Now talking about master-slave replication, when a customer creates MariaDB master-slave scheme, by default we provision 2 master nodes, two nodes, one of them master and another slave, and 2 proxy SQL servers for load balancing your SQL queries. And we do some configurations by default. You can see the list of parameters we tune for you. It's possible to adjust these parameters afterward. With master-master, we also create 2 nodes, but 2 of them are working in the master mode. And also there are 2 proxy SQL servers for load balancing your SQL queries. And you can see the list of configs we configure by default for you. With Galera cluster, we create 3 containers, 3 nodes by default. and 2 proxy SQLs. And there is a list of configurations we provide by default. Let's talk a little bit more in details about vertical and horizontal scaling. I love vertical scaling very much. I believe it's underestimated. I mean, the power of vertical scaling is underestimated. So, but what it means when I talk about vertical scaling? It means you can easily increase available resources per each instance, per each container. So remember, we run MariaDB instances inside isolated system containers. So, and you can adjust the limits on the fly. You don't need to migrate or you don't need to restart your container. And also, we provide additional automation reconfiguring parameters such as k-buffers and caches. So after you adjust the limit, the scaling limit, we need to adjust also MariaDB instance. Otherwise, MariaDB will not be able to utilize all these available resources. So we do it automatically for you. Please keep in mind it's possible to switch off this automation and configure manually. But in the majority of cases, it works just fine. Let's talk about the difference while scaling virtual machines and containers vertically. For example, if you go to infrastructure as a service and you buy virtual machine, right? Like so, and during some period of time, after some period of time, you realized you reserve it too small. Limits, let's say, what you need to do. Like there are 2 issues. First of all, you need to buy, in the most cases, twice bigger machine, because the majority of infrastructure service vendors, they do not offer you very granular vertical scaling, so they force you to buy twice bigger amount of resources. And second issue, you cannot just add new resources to the same virtual machine. You must migrate instance from the existing one to a new one. So there is a manual work behind this vertical scaling, which is not very convenient way to scale your MariaDB instance vertically. If you scale containers specifically within Jelastic, there is a possibility to increase and decrease scaling limit on the fly. You don't need to do anything else. I mean, like migrating to another container, or buy like twice bigger amount of resources. You can add as much as you need specifically. So it's very flexible. It's much cheaper and faster to scale MariaDB with containers. And another advanced and very powerful functionality and feature we call pay-per-use billing model. And it's so powerful, many customers allow it. And as soon as they realize how it works, they relax and they keep using Jelastic even more, start using Jelastic even more. So how it works? For example, when you go again like to infrastructure service, you buy virtual machine, let's say like 16 GB of RAM, right? But in the most cases, you don't utilize everything because you buy a little bit insurance just in case if more load is coming to your instance. So your instance should have some capacity to grow up. And also another issue, many customers, they use like dev and stage environment, and in these environments, resources just idling, so you don't utilize them. And it means there are a lot of resources that just underutilized, but it does not matter, you always pay for the limits. This model is called like pay as you go. Why pay as you go? Because when you run your virtual machine, when it's running, you pay, but it's regardless of the consumption inside. When you stop, you don't pay. So it means like pay as you go, pay as you run. But in Jelastic, we introduced new different model, which we called next generation and cloud native pricing. And it works in the following way. You can set scaling limit, but if you don't utilize up to the scaling limit, you only pay for the amount of resources your instance consumes. We believe it's much fair and it's more flexible billing model for end customers. So it gives 2 main benefits. First of all, you save money for resources you don't consume. And the second, it solves right sizing problem. You don't need to guess in advance how much resources to order per each container. Just imagine if you have many environments, if you have many containers, it's very hard to predict in advance what the load will be during the time. So within Jelastic, this problem is just solved because you set high scaling limit for your MariaDB instance, and that's it. If MariaDB is consuming this, you pay. If it doesn't consume, you don't pay. Very easy and flexible. Good. Let's talk now about horizontal scaling, how it works within Jelastic. We're coming back to this topology wizard, and you can see there is a plus and minus button. So it means you can remove or add new instances with MariaDB. And the good point, these instances will be automatically added to your cluster. Depending on your scheme, if you work like master-slave, it will add more slaves. If you work like master-master, it will add more slaves as well and connect them to the masters. If you work in Galera mode, it will add more masters. And there is another interesting drop-down, like mode for scaling. It's possible to choose stateless or stateful scaling mode. What it means? It means stateless mode, when you scale in stateless mode, we create new empty container with empty MariaDB instance. And then you need to configure, if you do it manually, actually, clustering manually. But in Jelastic, it's automated, but just for your understanding. So it's empty container, and you need to configure replication, and data will go through replication to this new container. In stateful mode, we clone master node with whole data inside, and it just connects this to your cluster afterward. So it's much, let's say, the data will be in this new container. So this is the difference between stateful and stateless scaling. Let's talk now about specific details, how it works per each schema. Let's talk about master-slave, automatic horizontal scaling. When customer press a plus button and we add automatically new node, but first of all, we drop one slave from proxy SQL load balancing distribution list. So then we stop the slave and we clone the slave in a stateful mode. So we clone with the whole data. Then we start the original slave and return the slave to the proxy SQL load balancing list. Then we adjust configurations of the recently created slave node. Specifically, we adjust server ID and report host, and we launch this new slave and add this to the proxy SQL schemas. And as soon as all transactions are applied to the new slave, proxy SQL will distribute the request to this new node as well. So this is in short how it works. You can find the link to the logic, to the source code of this logic, so you will be able to analyze by yourself how it works. Good. Master, how it works, automatic horizontal scaling. First of all, we drop second master from the proxy distribution list. So only one master works if you have only two nodes. And then we stop the master and we clone this master in stateful mode as well, with the whole data inside. Then, similar to the previous algorithm, we start the second master and return this to the proxy SQL load balancing distribution list. We reconfigure cloned node as a new slave, and then we launch this new slave and add this to proxy SQL list. After this, this new slave will be able to handle new requests. If you scale more nodes, I mean, if you add more nodes horizontally, we add new slaves only in these schemas, but these slaves will be connected proportionally to every master node. So, for example, if you have 4 slaves, 2 of them will be connected to one master and 2 of them will be connected to another master. Please feel free to analyze the logic, which you can find under this link. Now let's talk about Galera cluster automatic horizontal scaling. When customer press plus button, we create new node in a stateless mode. So we create a new empty container with empty MariaDB. Then we pre-configure some parameters and we add this node to the cluster. And we also add this node to proxy SQL, but without distribution. So as soon as all data is synchronized through the state snapshot transfer, And as soon as the synchronization is complete, proxy SQL will include this node into the distribution list. So, and this node will be able to handle new requests. If you add more nodes, it will work in the same way. But we were talking about when you press plus button manually. It's possible to add more automation to your cluster with auto-horizontal scaling triggers, thresholds, let's say. For this, you need to go to settings of your environments and switch to auto-horizontal scaling tab, and you will see there are different thresholds based on CPU, memory, network, and disk. You can specify when to add new node. For example, based on CPU, when the load is more than 85%, please add one more node. And please remove this node when load is go down below 35%. It's just an example. So you can fine-tune these parameters and configure fully automated horizontal scaling. Please keep in mind, after this new node will be added, all logic, all automation I just described previously will be applied automatically for you. So you don't need to do anything actually. In addition to automatic horizontal scaling, there are useful load alerts we configure by default for you just to let you know when load is coming close to the limits. We configure load alerts for CPU, memory, disk, and inodes as well, and network. So you can adjust this default load alerts, or you can add your customs. It's very useful again to understand maybe like you did not configure horizontal scaling for some reason, right? Or you want to get alert when it's coming close to horizontal scaling. So feel free to use this useful functionality. But also we take care about OEM kills, because sometimes OEM kills happens. When it happens, when load inside the containers is coming close to the available limits. I mean, as well to the limits of available memory, right? And then system will kill instance of MariaDB. So what we do in this case? First of all, we adjust configurations. So if you use our default configs, I mean autopilot mode, let's say, then our system will automatically reduce a little bit InnoDB buffer pool size, like on 10%. And then restart MariaDB instance and see how it goes. Like if another OEM kill happens, then it will repeat the same exercise. So it will reduce a little bit InnoDB buffer pool size. So in such way, we want to avoid any OEM kills. So you can adjust how much per each step to reduce through specific parameters, let's say, right? Specific environment variables. Or if you don't like it for some reason, you can just enable auto configurations at all. So, but I do recommend to use this autopilot mode. Extra functionality for extra protection, for extra high availability, anti-affinity rules. When you create two nodes or in the same environment of MariaDB, we don't place them on the same physical box. We distribute them across our infrastructure. So we put this MariaDB into different host nodes. It means when one host node fails, your cluster will keep working because there is still one node is available. By the way, if you create like 5 nodes, it will work in the same way. Like if cluster, I mean, if there are 5 physical nodes behind the main cluster of your cloud service provider, every instance will be placed into a separate physical node. So in this way, we ensure extra protection for your environment. For the most advanced people and for the most demanding who want to do extra configurations, who want to attach custom logic while scaling, Jelastic offers events, different events. You can attach your custom logic to these events. You can see what kind of events we have. You can go to the documentation page and review how it works. The logic should be written with help of cloud scripting. It's pretty simple declarative language. But you can also just inject JavaScript language, Java scripting, let's say, yeah, and create extra logic for you. So call extra APIs or even call some SSH commands and do some extra logic inside the nodes. So very useful. We actually use this functionality to configure our auto clustering logic. Great. However, you know, like sometimes cluster within one data center is not enough because huge disasters unfortunately happens. And recently, as we know, one data center of OVH was completely burned out. Like, you know, like it lost a lot of data and a lot of customers were damaged. It's a very serious issue, right? Like, unfortunately, again, like nobody can be like protected from such kind of disasters because like maybe it's like human mistake, like, or I don't know, like maybe some hardware did not work well. But how we can help our customers to be even more protected? For this, we offer and we do recommend to use multi-region and multi-cloud deployments. And it's not easy, honestly, to configure clusters in different regions, but still, Jelastic offers simplicity to deploy into different regions, to different clouds, and manage in the same way with the same API your clusters in different regions, in different data centers. So you get real full interoperability. But even more, to make life of developers and DevOps team even more easier, we work on advanced automation on advanced packages that can deploy clusters into different regions and configure synchronizations between these regions. For example, here you can see like multi-region deployment of WordPress clusters. It works in the following way. Like we deploy WordPress cluster, which includes MariaDB Galera cluster inside into 3 different regions. And then we configure synchronization and replication between these Galera DB instances across all regions. So if one region goes down, your application will keep handling requests. So in Jelastic, such kind of complexity is hidden behind one-click button, literally. So you just choose a package, you choose regions, you press button deploy, and then you enjoy. For the most demanding customers, there is a possibility to adjust and fine-tune configurations, but for the majority of customers, it just works fine. So that was in short about MariaDB within Jelastic. If you have more questions or any questions, please feel free to contact me via social media or just send message to info@jelastic.com. But also, I suggest you to try by yourself and play by yourself and get familiar how MariaDB clustering and horizontal and vertical scaling works in Jelastic. Please sign up at this page, try it out, and let us know what you think. Thank you very much. Be safe, and I hope to see you soon in person at some conference. Yeah. Bye-bye.
Great presentation, Ruslan. Thank you.
Thank you too.
I think it was very convincing. At some points, I thought it was a bit too good to be true because most things were automatic. And while I think that's good, as a user, I would be tempted into a state where I don't understand the underlying logic. Everything is automatic anyway. So given that this and that is automated, what is left to do manually?
Okay, very good question. So you still need to think about your backup for now, like, right? So it's coming in the near future, but for now you need to uncomment some scripts and you will back up the system. Also, you need to do upgrades to a new version. So you need to at least initiate. We have automation for this, but you need to initiate upgrades. We don't upgrade automatically.
Upgrades of MariaDB Server, you mean, or?
Yeah, upgrade of MariaDB version, like software version, like the MariaDB server. So what else? I don't know. It's mostly optimize for your specific application because it really depends on your application. So you
Right.
need to tune some configs. Like we cannot do like magic for everyone.
Of course,
In
and
the
that was the root of my question. So, like the settings, I saw there were some settings that you displayed in your video. So, what are the most important settings?
Yeah, of course, buffer cache, let's say. So we configure it based on available memory. So more memory you give, more buffer you get. Like, but you can adjust it based on your needs. Like so, and yeah, and the rest actually you need to go and deep dive. Like in the future, we are planning extra automation when we learn based on the load patterns during the time. And then we update these configs, but it's not available yet. So for the next releases, let's say.
So let's say that I'm on the settings page, and that's a bunch of numbers. How do I get help in setting them? I mean, I can clearly experiment, and some of them are somewhat self-explanatory. But how do you have any kind of documentation on this, or is everything that can be documented also automated already?
So regarding settings related to MariaDB specifically, you need to go to MariaDB website and learn from that website, like what they mean, like, because it's not what we do. Our goal is to automate provisioning and some initial configurations and scaling. But if you want to tune, so please visit MariaDB website and learn specific setting, let's say, like, yeah. Mm-hmm. So information regarding specific setting. That's how it should be done. Yeah. Or if you don't want to do it, or you don't have a time, just send a request to your service provider, and they will be happy to help you for sure. Like, so they will be able to optimize.
One thing that you spent a lot of time on there was horizontal scaling, which is automatic, and vertical scaling, which is sort of also automatic. So how do I pick, or how does the system pick when it does horizontal and when it does vertical scaling, and how do I myself say which way to scale?
Good. So vertical scaling work by default automatically up to the limits you set from the beginning. So you set like, okay, like maximum scaling limit vertically, let's say like 16 gigabyte, like, or like 32 gigabyte, right? So it will work up to this limit. You can increase this manually after you reach the limit in case you need more resources. But the good point here that you don't need to think in advance about the sizing. So you can go high from the beginning, because in Jelastic, you pay for what you use only, literally. Like
you made that point quite well. I think that made a lot of sense. Any concluding like 20-second remarks that you wish people to take away?
Yeah, so please, when you upgrade, please create staging environment. Like, so don't upgrade on productions, like play before, like don't apply everything directly on productions, please. So that's very important, because we see people do it often. Like, so play safely.
Makes a lot of sense. Thank you, Ruslan Sinitsky.
Thank you too. Thank you too.
And now for the first very interactive moment out of this HA MiniFest. This is not pre-recorded. This is going to be live. Let's see what happens at the panel discussion between all the presenters. Welcome to the MariaDB Server HA panel. We have invited every presenter and interviewer to the panel, and I'm happy to note that most could actually also come. So this panel has 2 or 3 phases. The first phase is a discussion amongst the panelists themselves, then followed by audience questions, separated into 2 categories. So first, my 2 co-moderators, Ian Gilfillan. Hi, Ian.
Hi, Kai.
And Vicențiu Ciorbaru. Hi, Vicențiu.
Hi, Kai.
We'll ask questions on your behalf, on behalf of the audience, as you type them on Zulip. That's our chat. And you can join the Zulip chat very quickly and easily. You'll find it over redirect mariadb.org/minifest chat in one word. mariadb.org/minifest chat. and that then directs you to the login screen for the topic of this very chat. So there's really not many seconds after you typing in the URL mariadb.org/minifest chat and you being able to ask questions to this panel. So then after the panelist only part, we will open up the Zoom chat and make it into a hallway discussion. And that Zoom URL also has a shortcut URL, which we have sent out to those of you who have registered for this HA day. And when we're ready to open up the floor, we'll share it also here with the rest of you so that you can join Zoom. So when we're ready, you'll be let in into the hallway by Anna Videnius. But now for the content. So really short background, experience has taught us that focus on the end user perspective is what you like. That's appreciated by the core part of the audience. And this, of course, fits very well with the MariaDB Foundation focus on the adoption of MariaDB Server. And the conclusion from that is that we will give special focus to Pedro Albuquerque of TransferWise, or WISE as I hear it's now, and his presentation. So hi, Pedro.
Okay.
And then to strengthen the user perspective, I've also asked Eric Herman to join. He's doing that not primarily as chairman of the MariaDB Foundation, which he also is, but wearing his hat as an experienced user of MariaDB Server, and mostly taking off his hat as a contributor to the MariaDB Server codebase. Hi, Eric.
Hello, Kai. Thank you for having me.
And the non-vendor side is also represented by Federico Razzoli, a consultant at Betabase. So hi and welcome, Federico.
Hi, thank you, Kai.
And of course, we're very grateful for our vendor presenters from MariaDB Corporation, Max Meter. Hi, Max.
Hey, Kai.
And then from Jelastic, not Ruslan Sinitsky, but Ihor, now I forgot your last name, but welcome.
Yeah, Karl Duk. Nice to meet you. Nice to see you.
Great. So my first question will go to nobody other than Pedro. So in the Q&A session, you got the question from Ian about Postgres installations, and you described how you got your Postgres installations. So how did you get your MariaDB installations? You said at some point that when you came there, it was MySQL 5.6.
Yeah. So when I arrived at WISE, we had more or less like 50-50 Postgres and MySQL, but we were having big troubles with MySQL, especially on our monolith, and not only with performance issues, but also we were limited by the fact that we couldn't do a lot of online operations when it came to schema changes.
Mm-hmm.
MariaDB gave us that more online TDL operations. We also faced since I think we still have the biggest source code for Grails, and this we were having troubles, for example, with misbehavior of Grails when it comes to handling transactions. So it would keep transactions in an idle state, so opening, locking a lot of objects, and MariaDB gave us as well the possibility to set timeouts on idle transactions.
So how did you know that? I mean, that's true that MariaDB gives you that opportunity, but how come? How did you know it?
I think just curiosity, looking for what is around. I know that Postgres at the time, we were running at the time with 9.6, if I'm not mistaken, and Postgres already gave us that. And I was looking at, since the migration to Postgres would be extremely difficult. So I kind of like understood. I looked at what are the other options instead of migrating to Postgres. What is available, and found out that MariaDB it would answer a lot of our issues.
Mm-hmm. Makes sense. So what about the other panelists? I hope you've seen Pedro's presentation. What would you like to ask Pedro?
So Pedro, I'm very curious how your migration process went. So we try really hard to make it easy to migrate to MariaDB. I'm curious if you run into any problems or setbacks, and if there's anything we could have done to make it easier.
At the time, 5.6 to 10.2, if I'm not, yes, it was migration 5.6 to 10.2. It was very simple. Like we didn't have to do anything, basically. We just had to confirm that the drivers would be compatible. And we would have to block any DDL conditionals, let's say alter table or add column, if not exists, as an example, because it was not supported in MySQL at the time. So we have to some kind of have block anything that could break replication. So the migration was basically for the services that we did not require uptime, so like not customer impact, we would basically go with basically like dump and restore with the service down. When it came to services that had customer impact, we would have to set up replication from MySQL into MariaDB with no issues at all. Honestly, it was very, very, very smooth.
I have a question for you. So when I was in a environment that had heavy uptime demands, one of the things that was top of mind for me was always, what is my reversal plan? And often I would discover that I wouldn't need a reversal plan because any problems would have shown up on the first node that I migrated, but sometimes it wouldn't be all the way up until I had switching over to the primary read-write instance that I would discover that I needed something, and then I would need to switch back. And so practicing that was something that was important for my team when we were doing those larger upgrades and migrations. So did you think through a plan like that, or was it so smooth on the first few that you didn't feel the necessity for that?
No, we have so we at TransferWise we have autonomous teams, right? So each team is accountable for their stack, the whole stack.
Sure.
But the database engineering is there to help anyone and to give any kind of best practices, do some kind of governance across the whole fleet of databases. When it came to migrations, we have different environments before production, right? So we have environments for that are used for different partners to test integrations. We have staging environments. We have other environments that developers just pin up and test some features. So before we actually migrated production, all these environments were already running in the new version. So we were pretty confident that we wouldn't have any issue Not like 200%, right? But
sure, but
because
yeah,
it's
you had
extremely difficult to replicate production workloads exactly as it is. So, but we addressed all these issues with upgrading these environments that were not customer facing.
right. Cool, understood. Thank you.
So calendar time wise, how long did the whole migration take? I mean, you had quite a big cluster there.
It took around a year to migrate everything because we were a very small team. We were about, during the migration period, we were about 3 database engineers, 3, 4. And we also had to support, right? We also had to support the current needs, so the operational, the daily operational tasks. So it took that long. Including the whole set of databases, right? Not only MariaDB, but also Postgres. With Postgres was a little bit more complicated.
So what did you do for Postgres migration? I got the impression from your talk that Postgres is Postgres and MariaDB is MariaDB, and you do not migrate between them because you see no point in so doing. And you now also said that there's a lot of friction or a lot of difficulty, and you seem to have a team that knows MariaDB and a team that knows Postgres. So is there any fluctuation between the two?
There are, since they both have been around for so long, we actually considered migrating from Postgres into MariaDB, right? Because apart from a couple of teams, we could live easily with MariaDB, but it would be extremely costly for us to do that migration. Not only a lot of teams are used to Postgres, right? So they would have to change, do some code change, and also change the way they interact with the way they interact with database, the way they are used the database to work, but also in terms of time, because we believe we have other and more important battles to fight, rather than putting so much effort in migrating. So we understand the cost of maintaining 2 relational databases. We understand that, but at this point is not our priority.
So we've been bombarding you with questions. I think we should now relieve you a bit and instead give you the opportunity to ask the other panelists something.
The other panelists, unfortunately, I was not able to attend today's talks. There was a lot of work, but and this is more for also for MariaDB Foundation, and is, as you could see from my talk, we had to use other components that are available to be able to have this failover in place, right? Do you think MariaDB should go and integrate this mechanism within the engine itself, within the software, rather than relying on third-party tools?
So I think this is on a case-by-case basis. We will always rely on third-party tools, but we will also integrate whenever we can. So I think one of our answers is, where do you see benefits from that integration? But I think, Vincenzo, you might be better equipped to give a more technical, deeper answer to the same question.
Yeah, so I agree with Kai that it depends on what exactly you want to achieve. Now, there are different integrations for different tools. Like we even have, we don't have something for HA like failover per se, but we have lots of tools to integrate to get you more data easier. And I'm sure Max can talk about the Xpand storage engine when it comes to scaling writes. And I think in some sense, Xpand also has load balancing built in. And then there's other storage engines like Connect that help you link with other sorts of data. But I don't think that we should focus on that. I think we should more focus on Xpand this time.
Yeah, and I think also, Max, you should answer for MaxScale, since we don't have Johan here, speaking of integrating things. So over to you, Max.
Right. So first of all, I agree that it depends, right? I think in some cases, the database itself could do some of the let's say talk between different nodes, but like for example for replication, which is so clearly asynchronous, I feel like it makes most sense to have it outside the server. Like, I mean, MaxScale is one of the tools that can do that. Like, I don't know how much we discussed MaxScale, but MaxScale obviously monitors replication status. If the master fails, it initiates a failover, makes one of the replicas become the new master, and sets the other replicas to start replicating at the right location. So that seems like it would be, considering the asynchronous nature of how many different topologies, it seems like it really is better suited to be outside the server. But for something like Xpand that Vincenzo mentioned, so there I really feel like something like that could be more integrated into the server. Same goes with Galera. I think Galera obviously is integrated into the server, but there's no cross communication on the upper level between nodes, but there is cross communication on the lower levels. So I feel like maybe there could be more integration, that you can use MaxScale both with Galera and Xpand, but in both of these, I think, I question whether you really have to have something like MaxScale there, or it could be done somehow in the server. But obviously none of that has been done yet. But it is something we're actually looking at. We're looking at specifically for Xpand, but I think for Galera as well, there could be some things that could be done on the server level.
So Ihor, I think one interesting thing to add a perspective on this, since your presentation was about automated this and automated that, so it's integrating lots of different tools. So Ihor, your perspective.
Yeah. So what we used to do, we used to work just in containers where you can scale resources just dynamically, and we trying to adjust configuration on fly. So what MariaDB gives right now, ability to set things like in a DB buffer pool size online without restarting the main process, and we also adjusting stuff dynamically. For example, if killer was triggered for some reason, the configuration was not stated properly, the system tries automatically to decrease possible values to set them dynamically and start the instance. So one thing, the instance is automatically configured during the changes that are done by the customer online, with depending on limits. Another change is done automatically if the admin is not interacting the service directly, and if something happening on the background, because if the configuration usually is not adjusted by itself, so the system in our case looks after that, and if something occurs like killer was triggered, the system tries to adjust it accordingly to possible safe values, to avoid these regular restarts. So yeah, the automation is the key, and it would be nice if in MariaDB engine this stuff could be added as a native thing, because for now it's like a third-party tools are managing all these things. So that's one of improvements I would like to see in nearest future in MariaDB to be available for everyone.
Thanks, Igor. And by the way, we'll continue this very question on just mentioning to everybody listening out there that you can join soon the hallway. You can just go to mariadb.org/hallway, and that will redirect to the Zoom, and you will be in due course then let in. So mariadb.org/hallway. But I'd like now to hear the following persons. I'd like to hear what Federico thinks about this, and then we'll return to Pedro, because you got a lot of answers.
So can I jump in there? Because I see that in the Zulip chat, somebody has pointed to MDev 7502, which is automatic provisioning of slaves. So this is one of the tasks inside MariaDB's issue tracker. So that sounds like it fits what we're looking at here. So I suggest going and making some comments on that, or adding some words to it, which will help increase its priority.
MDev 7502, did you say?
Yes.
That's as a side note. That's something we're planning to add to MaxScale. It's on our MaxScale roadmap already. From the server, it seems a lot more complicated, but potentially could be done. But from MaxScale, it's easier, right? But yeah.
I also want to note that there is a clone server, a clone slave command, I think, for MySQL that sort of achieves the same result. And I think that's something we should also look into.
Can I use this last observation to ask one question, but more general, probably?
Sure.
Suppose at some point MariaDB finds new way to do certain things, much more optimal, to be much more fast and reliable and everything. But suppose this implies that it will become substantially incompatible with MySQL. In this case, what will you do?
Who should answer this?
Yeah,
I don't know anyone from MariaDB.
Max, you answer first, and I'll also give some kind of an answer. But Max, go ahead.
I mean, my answer would be we should absolutely do it. Obviously being compatible with MySQL has been very important in the past, but I mean, we are growing further and further apart. So I don't think we can have, I mean, it's going to grow larger and larger no matter what we do. So I wouldn't want to, like tie down the further innovation by being tied to this compatibility. And maybe instead you can, if you can, let's say you can if you're using MySQL and you want to get to Maria, maybe you have to go to MariaDB 10.5 and then you upgrade to, let's say we add this feature in 10.7 and then you go through MariaDB from 10.5 to 10.7 or something like that. So I think there will always be a path to migrate, even if we do something that somehow breaks compatibility.
Yeah, I have little to add to that. I could say the same things in different words and from a foundation perspective, but it absolutely is the same thing. We will add stuff. There's no reason to hold back in order to remain at a compatibility level where we haven't been for a while anyway.
I would like to chime in. I think that coming back to the earlier question of the different components, and should things be in the server or third party, I think it's very natural that things start out outside, and then as we as a community learn what's extremely important, we find different strategies for doing those tasks, and eventually we see the ones that are of highest importance gravitate towards either being shipped with the server or possibly with the connectors, or maybe inside the server code itself. And some examples of this that I can think of are when we were doing alter tables, it was a long time that only a few things were really online. And so we had various strategies for approaching that. And we saw that we had Percona's toolkit with the online schema change, which I used plenty of. It was wonderful. We then saw some innovative approaches with like the Ghost, the which introduced more flexibility. And that need that we all had together then gave rise to seeing in the server more emphasis put on being able to do more and more of these changes as online non-blocking operations. And so I think that that's an example where we, as developers and as system admins that are operating these especially the larger networks of servers, we find that we have challenges because we're operating on the edge of really well understood space, and so we build tools to deal with that that space that is not so well understood. But as we understand that very well, we're able to more clearly understand which things belong in the server and which things really belong as an external tool. And I think there will always be some tension there. It's never going to be a clean line. But I would expect that we would continue to see that continue to grow over time along that same trajectory. And I'm also very hopeful that if some of those things mean that the product evolves in ways that makes it not even excellently compatible with itself, I don't expect MariaDB 10.7 to have bidirectional replication with MariaDB 10.1 for every type of operation. We'll understand which things will work in each direction, but we'll also understand that some things will not work in both directions. And so we'll have to limit, when we're doing our upgrade and rollback plans, we'll have to limit ourselves a little bit during that transitional phase. And so I think that that's a natural part of evolving the server.
So Pedro, have we digressed far from your original question? Where was your question illuminated by the plentiful answers?
Yeah, definitely. It's looks like there is some kind of a consensus that depending on the use cases and the needs, it's good to see there is some opportunity to, like Eric mentioned, to move some things that make sense to be shipped with the server, to make and features, to reduce the complexity, to have in this case more uptime. So it's good to see that.
Thanks.
I see another MDev mentioned in the chat here is MDev 19140, which is full synchronous replication, so that the cluster as a whole gets notified about membership changes. Both of these tasks are assigned to Andre, so it looks like we need to clone Andre and get going there.
Yeah, I can comment on that one. It's something we have from the corporation had on our wish list for a while, but unfortunately it's a rather big task. So, but it's on my personal wish list as well. But I'm a bit doubtful it will happen anytime soon, but I would really like, I would love to see it, but I just, it's hard there's a lot of priorities. So, but yeah, I would love to see it soon, but I doubt it will happen.
So we don't have any absolute hard stop for this panel, but I would like to start soon wrapping up and asking for some concluding remarks, and then we'll give the privilege to Pedro to do the last concluding remarks, but perhaps Vincenzo, some comments or perhaps even still a question from your side.
So I have another question for all who are seeking to automate stuff with MariaDB, and actually mostly concerning observability. So I'm sure that Igor has some thoughts as to what MariaDB could expose more that would help automation and make his service scale better. And I'm sure Federico has lots of war stories when he did the consulting for different companies. How hard was it for both of you to figure out where things go wrong? Where do they scale improperly, or any other troubles you might have?
Okay, Ihor first.
Yeah, so what we usually do, we analyze in production. So we're running more than 100 data centers across the globe, and we gather in logs. So we're trying to analyze what people usually do, what mistakes do they do, or what things are in configuration files are always wrong. So by analyzing these, we always facing with the issue that people are usually not tuning their database. So most of people are using everything by default. So the best thing what we could do from our side to make the configuration most like suitable from default view, like to cover most of cases. So that's a place where this automation came from. So we're trying to fit 90% of cases just without triggering a person just to adjust their configuration, because they anyway they don't do this. So what could be improved better just from our case. There's the mechanism that responsible for automatic adjustment if the configuration is not set. So for default values, maybe default values is something that need to be reviewed and changed, because some of
Can we get a pull request from you on that? Please, please.
Okay, thank you. So yeah, the thing is that many settings from configuration files were designed quite some time ago, and that time changed, and the data models are changed, and the way how people are interacting with application changed. I think the default things need to be reviewed, the default settings, and if it is possible to make something flexible, that's better to do this. So that's my vision.
10.6 is coming up. Now's your chance.
So Federico, your take.
So I think in general, observability on the things that applications do. So for example, there would be better to have more observability on what transactions do, because I give you an example. It's very common to see the number of threads running grow, and then experience say that it's because there is probably some long transaction, but it's not very easy to prove it. And it's not very, at least it could be easier probably to have some tools or some kind of, variables, whatever, telling us what such transactions were doing. And another example is about temporary tables, because this is another thing. If applications create big temporary tables and then they consume a lot of memory, well, how to prove it? It's not easy. So these are only two examples that I could find from the top of my head. There are probably others, but I would say in general, observability could be improved about user queries and user transactions and similar things.
So Max, not necessarily about observability, but given that you're representing MariaDB Corporation, both towards the foundation and now on this MariaDB Server High Availability Day, is there something around the topic of high availability that you wish to add and address?
No, I think most of the different technologies here have been discussed. I do think there's a point in observability in general, improving that could be done, and that goes for high availability as well. It's not always easy to figure out what's going on in a high availability setup. So I think maybe that's something to look at too. Even in Xpand, we have that issue. Xpand has a thing where it does something called a group change, where there's a failure in the cluster, and they have to figure out, can they continue as a cluster, and it turns out even that is not easy to figure out why suddenly they're doing something else than responding to queries. It's because they're making sure they can continue, but it's not clearly observable from an outside. So I mean, I think that's a good point as well.
Cool. So Ian, either observations or questions or comments from you?
Any comment ready to expand on Eric's request for pull request? So to anybody watching, even if you're not able to do a pull request, I suggest interacting with our Jira instance by creating a new MDiv or by voting on it. Because although if you vote on something like the full synchronous replication, doesn't mean it's magically going to get created, but it does give the developers some sort of indication about what the needs are, what the priority should be. So I encourage you to use that tool.
Good point. Thanks, Ian. Converging soon back to you, Pedro, the other user representative here. Eric, what's your thinking now, wearing very much a user hat?
Well, the things that I think have been said by others, but I'll highlight the being able to do everything online, never having to restart the instance. That's what I want, and seamless failover would be lovely. But really, I've had more pain around. There's a setting I wish I could change, but it's not dynamic. So I'm going to introduce a primary read-write instance failover because I need to change one setting. So hopefully all schema changes are online, and essentially everything is modifiable live. That's my dream.
Thanks, Eric, for sharing your dream. Do you have any remaining, Pedro, do you have any remaining dreams, or have the comments here meant that all your dreams have come or are soon coming true?
I think I'll make Eric my words. Looks like we share the same dreams. One thing that Ihor raised and was about the possibility to have better defaults, but one thing that we face is managing so many databases, and whenever we need to scale up or down, it would be good for some settings to be adjusted with the current hardware, so we don't have to change where it's on Ansible, where it is on AWS console on RDS. So having this, having the server to adjust the settings to adjust to the configuration, to the hardware configurations, would be great. That would be
something
great.
Like InnoDB dedicated server in MySQL.
Something similar. For example, if we have a 3-node cluster with replication, right, and adjusting as well the replica threads, let's say, with the workload. So the server to be smarter on that sense.
Yeah, one of issues I wanted also to mention that it's easy for containers, but much more complicated for combined VMs where multiple services are running, because if it's so hard to predict. Of course, it is possible to analyze the hardware just at the moment where the service is running, just to determine if the hardware is good enough for some particular settings, but you don't know exactly how to predict the behavior of other applications where your, for example, VM is shared with MariaDB instance, and the case is good for us because we're using containers and the instance is dedicated, and there are not so many things are running aside near main service, so we can exactly predict and know what things we can to adjust. But in case of combined installations where the role is mixed with something else, we cannot predict what will be the behavior of the application which is running aside. just to not to get resources more than it will be possible to use later than, for example, in an hour or 2 or 3 if after some time.
Yeah, that's a good point, of course. Yeah. We have to take that into consideration.
Excellent. Well, I think those are good concluding words. Thank you, all the panelists, for good insights and good feedback to us. We know now more what your desires are. I also want to underline what Ian said, that your feedback to us over Jira in voting on issues and in commenting on issues is valuable. It might not move the needle immediately, but that's the only way in which we can learn about your priorities. So this has been the MariaDB Server HA High Availability MiniFest. Thank you to the panelists, and above all, thanks to the audience. Until next time, bye.
Thanks, everyone.
Thank you.